I think we probably should make a start to this. Feel a bit funny in a vast room like this. And it's not full by any stretch, so why am I in the biggest room? Anyway, I guess because it's probably the most appropriate for the tutorial rather than the buffs and so forth that are happening in the other sessions. Can you all hear me okay? I've got the usual problem of being too tall for the microphone, which is fixed. It just doesn't move anywhere, so I might have to hold it in hand. So this is, well, BGP troubleshooting tutorial. Actually, I'm going to hold this. This BGP troubleshooting tutorial, it's the third in the series of BGP tutorials that I have been doing at NANOG for a few years now. The level of this is introductory, as I said in the abstract. I think if you've used BGP for a few years and you've had to deal with the usual customer-peer upstream interaction and figuring out the problems there, then you could probably stand up in this podium and do the same slides as I'm doing. But if you're relatively new to using BGP or you've had such a perfectly running network that you've never ever had any problems, then you can probably benefit from some of the experiences I've got here. A lot of these are culled from, well, I suppose, my own experience just with helping ISPs. I do quite a lot of workshops around the world, so these are hands-on workshops where people learn about OSPF, BGP, and so forth within an ISP arena. And so as you work through some of these workshops and people come up with some wacky, broken problems, then at least talking through some of the situations I have here helps people understand how to troubleshoot the issues within their networks. So there's a lot of examples from that contained in here. I've also culled quite a few from, well, Cisco's own support people, some of the situations they've come across, some of the common caveats that people don't think about, and so on. The other thing I suppose I should say right now, it's pretty hard trying to put together slides to do a troubleshooting thing, because one person's troubleshooting is very different from another's. You know, a major ISP is coming along and they have had experiences that probably nobody else has really had. So, and I'll say this at the end, but I'll say it also now, if you have other experiences and you would like to share them with the community, please volunteer to do a tutorial. I don't have to be the only talking head that does this. I'm not an operator either. I just sit and watch and help a lot of operators. So maybe that's a slightly better position to get a range of issues, but it's not a good situation to be in to get some of the more detailed, well, get exposure to some of the more detailed troubles that many ISPs are accustomed to. Okay, so presentation slides, they should be on the NANOG website by now. If not, you can also get them from the URL I've put up on the screen. They'll stay there for, well, at least as long as Cisco let me keep them there. But they'll be on the NANOG's website at least. I quite like this to be interactive, but if you're all too shy, that's fine as well. If you can use the microphones, and I don't know if the session's being recorded or not, but if you at least please use the microphones because it's pretty hard to hear when you're standing up here at the front. What else? I assume some working knowledge of BGP, so that's really beginner or intermediate experience of the protocol. I use Cisco CLI for all my examples. Sorry about that. It's all I've ever used. It's all I've ever used for about the last 15 or 20 years. Again, as I said earlier, if you would like to offer BGP troubleshooting experience on other hardware platforms using other versions of whoever's implementation, you may have the podium at a future NANOG. The program committee would be delighted to have somebody else apart from me rabbiting away up here. So if you'd like to do that, go for it. So anyway, all examples using Cisco CLI, but I'm sure a lot of them can actually be translated into your own versions. Okay, so what I'm going to cover, Fundamentals, which is pretty quick, just going over basics of how you do any kind of troubleshooting. Then we're going to spend a fair amount of time looking through local configuration problems, so it's both with IBGP as well with eBGP. And then we're going to, in the second session, the latter half of the second session, have a look at some of the internet reachability problems. So you're fine working in your network, but your customer's complaining about can't reach somewhere else on the planet. What do you do about it? And how do you go about doing a lot of your own troubleshooting before you get anybody else involved? So, looking at the fundamentals, well, the first step is actually to try and recognize what causes a lot of these problems. The possible problem areas can be misconfiguration. That's very, very common problem area. These can be caused by bad documentation, misunderstanding of concepts, poor communication between colleagues, poor communications between departments. Before I worked with Cisco, I was at UUNet for 5 years, well, the European UUNet rather than the US one. And, well, we came across lots of these things. Documentation, as most of you know, is never really done. It's the last thing you do, well, probably before, well, I don't know, you wash the windows or something like that. It is the absolute last thing that's done in any operation, unfortunately. Documentation usually exists in your colleagues' heads or maybe not, well, if that even. They go away on holiday and there's no documentation whatsoever. That can cause a lot of problems, misunderstanding of concepts, very, very common issues as well. People think they understand what you're trying to achieve, but they really don't. I see that a lot, especially in the workshops, people learning new techniques. They try them out. It's all nice and easy in the workshop notes or the manuals that are produced, but then when you translate them into real life, things go awry. Poor communication, well, we're all very good at that. Human error. Human error is a big issue. As I say, routers would work perfectly if humans didn't get involved with them. As soon as humans seem to log into them and do stuff, things go wrong. Most common, typos. Hit the wrong key in the keyboard, you don't really notice you've made a mistake. I'll show some examples later on of where that can cause issues. Using the wrong commands, simple accidents. Very common one is poorly planned maintenance activities. Yeah, I can do this maintenance work in 2 hours, and then 6 hours later you're still struggling to put the network back together. What else? More problem areas can be feature behavior. I mean, the common one that I've seen, certainly working in this side of the fence is, well, it used to do this and release whatever, but I upgraded mine to release whatever something else and it no longer works. Well, yeah, feature behavior, reintroduced bugs, whatever you want to call them, but these are well-known problem areas also. Interoperability issues. Well, the venerable old RFC 1771, now obsolete, had, well, lots of different interpretations, which led to lots of interesting issues. And then there are those beyond your control. If you could run the whole internet, it would be a perfect place. Unfortunately, you have to work with your upstream ISP as well. And, well, they make changes or they decide to do maintenance when you don't particularly want it, then it can have unforeseen impacts on your network as well. So once you've figured out what all the problem areas can be, you've got to try and work out what the solutions are. And the solution is not really about jumping into the network and just trying random things on random routers just to see what makes a difference. That seems to be quite a common troubleshooting that I come across, especially in the more emerging parts of the internet. Same as my minor rant in the lightning talk yesterday about deaggregation and so forth. So many people just fire things out here, there, and everywhere in the hope that something might work. With troubleshooting, if you end up trying to do this, you could end up with a worse situation than you had before you actually started. It's best to be really methodical about how you go through some of these things. Best procedure for unfamiliar problems is to start at one place. Start with where the symptom is, well, looks the worst, and try and work out what causes it. And then you work backwards through the system. So it will be something about not panicking. That's probably the most important one. And people all have different natures. Some people like panicking, and they just panic just because they do. Other people can be completely calm, even in the middle of a storm, and those are probably good people to have as your troubleshooters. Again, sort of remembering back from my past and so forth, You know, I'd have managing directors and CEOs and various other managers screaming about the network falling over. It doesn't make a very good environment to try and troubleshoot or fix a problem. So if you're a calm person that can ignore what's going on around about you, then it helps a great deal. The second thing there is creating a checklist. I mean, this is a subtle hint about, hey, write some documentation. But actually, if you create a checklist and you work through that checklist, you've then actually documented how you tried to fix the problem. Because the next time something happens, or even better, when you're away and the next time it happens, your colleague can look at your checklist and work through it. Actually, a lot of network operations centers tend to work like this. They have a documented list of known problems, and as more problems happen within the network, they document how they fix them, and it serves as future documentation for other issues. And I suppose the other thing is to try and start at the bottom and work up. I mean, this is the classic call center thing. You know, you call in, oh, please sir, my computer doesn't work. Well, is it switched on? But quite seriously, sometimes you need to ask questions like that. You know, having sat on a support desk and dealt with customer issues in my ISP days, quite often we had to ask that. Oh, well, you know, customers saying I've got no internet connectivity. And you sort of go through the whole thing while you check your own routers and all the rest. And it's like, well, can you check your own router? I can't ping it. And I've spoken to the telco and the circuit's all fine. Is it switched on? Well, of course it's switched on. And then 5 minutes later, you get the sheepish response of, oh, well, no, somebody came in to vacuum the data center and they pulled the router out of the wall or something. So it sometimes makes sense to actually think of the stupidest things, check them all first before you get into something more complicated. So yes, checklists. I keep referring to checklists all the time, and you certainly see in the later part of all this that when you're trying to diagnose problems further afield, it's actually really, really helpful to try and work through checklists like this. As I was saying, many network operations center staff do work through these when they try and diagnose and solve network problems. Okay, some of the tools that you have. Well, the system and the network logs are actually pretty useful. I've seen so many networks where, ooh, what does the system log thing do? Oh no, that just takes CPU on the router. Oh, there was a security advisory 5 years ago about, well, you could do some attack on a system log and it could crash a router. Well, if there was an advisory 5 years ago, don't you think it might be fixed by now? System and network logs are actually vitally important. If you have no idea what the router is doing, or even any other device, I mean, we're talking BGP at the moment, but if you have no idea what the router is doing, then you really don't have much chance of finding out what was going wrong with the system. So keep good and detailed system logs, both on the device as well as exported somewhere else. Exported somewhere else, it's even better if it's in 2 places. Again, that just gives you nice redundancy. If you can't get access to one of your log system, then at least you can go somewhere else and try and work through that. Keep a record of known good configurations. Don't just overwrite the current configuration because, hey, you know, it's an update that my whatever friend suggested. Keep the last known working configuration, because at least if you've done something that breaks, you can step back one. And don't just keep one known configuration. I mean, I've always just kept them all. Use whatever your favorite system is to try and do this. If you have the history trail and all the intermediate changes, at least you can figure out what happened. Keep a record of the commands entered on the router, who logged in, what they did, and so forth. That can be helpful too, because then you know the person who actually entered the fatal command that brought the whole network down. And then you can get them to help tell you what they did and put things back together again. Familiarize yourself with the router's tools. So is the logging of the BGP process enabled? You can make the BGP process quite chatty. Don't make it too chatty, but you can make it quite chatty so at least it tells what's happening. Are you familiar with the debug processes available on your particular implementation? Check the vendor documentation before switching on full debugging of BGP. And certainly in Cisco, if you do debug IP BGP with nothing else, and you've got a few full BGP feeds, it could end up being quite a shock for both you and the router. People never think of this one. I mean, it's been talked about a few times the last couple of days, traffic and traffic flow measurement in the network. NetFlow is a wonderful tool. It lets you find out what's going on. So if you see large unexpected changes and things happening in the network, whether it's traffic levels and so forth, or maybe with a peering and so on, it can tell you what's going on. Correlate customer feedback with what's happening with various connectivity. If customers phone up complaining, oh, I can't get to Google or something, be suspicious. It might not be the customer PC is broken or something. It might actually be something within your own network, or it could be something further upstream. So pay attention to reports coming back like that. Okay, so let's start at the beginning. Let's look at some of the local configuration problems you can have. I'm going to look through these four. The first one we'll look at is the peer establishment. Yes, routers establish a TCP session. BGP uses port 179. But how many people forget about this when they set up the routers first? They set up the routers and they've got nice interface filters, inbound, outbound, and all the neighbors and so on. And it's like, ooh, BGP won't come up. Well, did you allow BGP through the interface filters? Oh, do I need to do that? Well, yes, otherwise how do you expect it to work? It doesn't make a sort of silent exception. And I've come across this so often that I actually make a point of mentioning it here. I mean, it seems a bit bizarre to do it, but I make a point of mentioning it. What about IP connectivity? Certainly for setting up internal BGP, do you actually get the route to the neighbor from IGP or some other way? Because, well, if you can't see where the neighbor is, there's no way you're going to set up a BGP session with it. And then, well, open messages are exchanged, peering addresses have to match, the ASs have to match, at least the configuration of what you expect, and so forth. So that all should just work. If the sessions are not established, then, well, you've probably got no IP reachability, or you've got some incorrect configuration. If the peers are flapping, then you can be pretty certain it's a layer 2 problem. Or it might be a remote router problem, but it's more likely to be a layer 2 problem. So what about the non-established sessions? Well, I'm just trying to take a generic picture so we can both look at what iBGP and eBGP does. So here's a situation. AS1's got router 1, router 2. We've got an iBGP session between R1 and R2. We've got eBGP session between R2 and R3. And we look at the configuration, and we've got BGP logging set up there. So we've got the BGP logging here. Neighbor set up with AS1. So this is our router 1 peer iBGP, and we've got neighbor in AS2. That's our router 3 eBGP peer. And nothing's working. So why is nothing working? Well, we can do the BGP summary, and we see that for the iBGP peer, there's nothing happening. And for the eBGP peer, there is nothing happening. Okay. The state over on the right-hand side is actually pretty important. It lets you know what's happening with the session. If you see the up-down saying never, it means that the BGP session has never come up. The state will generally oscillate around between active, idle, connect, and so on. Connect means you've actually got a TCP session established, but or at least it's starting up. Whereas active and idle is just running around, waiting and listening. So what can the issues be? Well, for iBGP, obviously you want to check that the local AS is correctly configured. If you expect this one to be an iBGP neighbor, but you get the AS number different, then you might get something strange happening. Is the remote peer in the correct AS? Is it AS2, or was it AS3 or AS4 or something? I mean, these are simple things, but the amount of times I've actually been involved helping people trying to get the eBGP set up, and there's been a simple miscommunication about what the remote AS number is, or what the IP address is. So it's pretty important to verify with any diagrams you've got, or any documentation, correspondence with peers, and so forth. So we're kind of going to assume that IP connectivity actually works. I mean, I'm not going to go into the basics of, well, you know, is the interface plugged in, and is the circuit working, and so forth. That's some other tutorial. But we assume that IP connectivity is there, so we see what BGP is trying to do. So you can look at the TCP sessions that are running. And you see, well, we've got one TCP session here with this remote address, and the state is sitting in listen mode. And we've got the other one sitting here. That's also sitting in listen mode. Okay, so we've configured for these peering addresses. Switch on the TCP TCP transaction debugging. That basically lets you know what TCP transactions are happening between your router and the remote. And you find that you're getting a message coming from 4.4.4. Oh, okay. So sorry, going to 4.4.4, coming from 2.2.2. Well, wait a minute, what's happening here? So 2.2.2 BGP, what's that system, is trying to speak to 4.4.4. What's that system? So you can suspect there's something strange with the addressing going on here. So we look at BGP, and BGP says, well, local address 4.4.5. Wait a minute, we're trying to open the session from 4.4.5, yet the remote was trying to talk to 4.4.4, so there's something up there. Looking at the routing entry for 1.1.1, which is who we thought we're trying to talk to, and yes, we can find it is going by a serial interface heading towards, going towards serial 1. So we've got some kind of configuration mismatch here. And what's actually happened is the source address of the packets going out from the router are actually, well, the outbound interface. Whereas IBGP, the way we set up IBGP is between the loopback interfaces, without going through the reasons why. IBGP sessions are generally set up between the loopback interfaces for redundancy purposes. So we've forgotten to specify that in the configuration. And so what's actually happened is we should be sending the BGP messages out from the loopback interface, or at least sourced as though they're from the loopback interface rather than the physical attached interface. So we put in the update source loopback 0, and then things should actually work. Okay, so what we've done here, we've checked the IP connectivity, so IGP or static routes or whatever you're doing. We have a look inside TCP to see what's going on, and then we have a look in the actual BGP process messages to see what's going on there as well. And we check that what the remote is thinking it's trying to talk to actually matches what you've configured. And this is actually a fairly common problem. We're trying to run IBGP between the loopbacks on the router for stability. But if you miss the configuration, then the IBGP fails to establish. Again, it depends on your implementation. Some implementations are quite happy to establish IBGP sessions even if the addresses don't match properly. Okay. So that should bring up the IBGP session between R1 and R2, but we're still having a big issue between R2 and R3, which is the eBGP session. Now, if you've got parallel links, like here, you've got parallel links like this. This is one of the rare cases where you'll actually use eBGP multi-hop, where you set up an eBGP session that runs over multiple hops in the network. So we're trying to load balance over multiple links to the eBGP peer. So we verify connectivity. Can we ping the neighbor? Is a destination for the neighbor address actually in the routing table and so forth? So we can do the ping to 3.3.3, that's fine. Got to remember one thing. When we ping to the neighbor, the packet comes from the outbound interface. So the source address of the ping packet is the outbound interface. You're trying to set up the eBGP session between the loopback interfaces and the routers. So you actually need to make sure that the remote router can reach your loopback interface. So we send the ping coming from our loopback, we get nothing back. Okay? That means the remote router has got no idea how to get to your loopback interface. So router 3 then adds a route pointing to 2.2.2, so it'll be a static route basically pointing on both connections back to R2, and it's still not working. So now we look at the detailed part of the BGP neighbor, and we pick up the point down here. It says external BGP neighbor not directly connected. There's an expectation that an eBGP peer is directly connected, so it's one TTL hop away. And if it's not, then you've got to actually put a little flag in the configuration that says, hey, this neighbor is not directly connected. It is more than one hop away. And that is in iOS, it's the eBGP multi-hop configuration. So we add an extra line, neighbor, whatever, eBGP multi-hop 2, that says we can be up to 2 TTL hops away, and then the BGP session should come up. Okay, well, we're still having trouble with this particular peering. We've sorted out the connectivity issues. We can now ping between the loopbacks on both sides. So it should work, shouldn't it? Well, this is where you can start looking into some of the BGP events. I mean, I don't know how many BGP workshops I've done over the last far too many years, but this is the one that causes so many issues. And it's surprising. People just sit there and say, nope, it's his fault. Nothing to do with me. It's their fault. Well, go and talk to them. Well, why should I talk to them? They've made the mistake. And it's usually the mistake has actually happened locally because there's been some mistake in the exchange of documentation. And here's one way you can find out. People don't make much effort to find out what was going on. If you actually look at the BGP events, you get this notification message coming along that says, peer in the wrong AS. I mean, that's a massive hint that there's something wrong. So somebody's in the wrong AS, whether you've mistyped the AS in your configuration peering, or they've set up their entire network to be in the wrong autonomous system. But something is wrong. And of course, if they try and open a session with the wrong AS number, BGP basically says, no, thank you, I'm not talking to you, goodbye. And that's why the session closes, or doesn't establish. So R3 was actually configured incorrectly. For example, they might have used AS10 rather than, should have remote AS1, which was what was the expectation. So after that, things should then work. At least what happened after that is these messages will disappear. So that's a summary of that. Important one, remember TCP 179 through edge filters. Common mistake. So example snippet could be like this. Permit permit your neighbor to establish BGP with you or talk to your BGP ports. You need to allow both. You need to be extremely careful with eBGP multi-hop. Extremely, extremely careful. I mean, I talk more about this in the multi-homing tutorial. There's so much that can go wrong if you try and use eBGP multi-hop, and I've been at the wrong end of too many situations where people have just wantonly used it without actually understanding the issues. Remember to source updates from the loopback interface. You generally run eBGP between loopbacks like this. Watch for filters anywhere in the path. That can happen quite a lot. TTL must be at least 2 for eBGP multi-hop between directly connected neighbors. Because I say it's got to be at least 2 does not mean you set the TTL to be 255. That seems to be a common thing people do. Oh, well, I'll just make it 255, and then it'll take care of any infrastructure changes that my upstream or peer or whatever makes. Well, yes, 255 means 255 TTL hops, which means that somebody can probably talk to your BGP session from a long, long way away. So be careful. Actually, it's worth counting the number of hops to the neighboring router. Yes, passwords. Passwords on iBGP and eBGP sessions. Passwords have been used more and more on both types of peerings in the last few years. And of course, they come up with their own range of problems, and people sitting there in crossed arms, looking at each other saying, nope, their fault, not my fault. So let's look at some of the things you can have here. So again, in iOS, we can set a password like this. It's just an MD5 there just to try and protect the BGP session. I know the type 7 encryption there is not really exactly encryption, but at least it stops somebody guessing what the peering password is by looking at the configuration. Anyway, so we've got the password set up. Have a look in the log messages. Some people are fearful of switching on the log messages in the router because, oh, it'll overcome the CPU. I've never actually seen that happen in real life. So there's real no harm in switching on the log neighbor changes function, because at least it will tell you things like this. So if there's something wrong with the password chosen, or your neighbor doesn't have a password, or you don't have a password, at least your router will start complaining. So in this case, we've got no MD5 digest coming from the peer. Okay, if there's no MD5 digest coming from the peer, then, well, your peer hasn't set a password on the BGP session. So you get them to set a password. And the peering should come up. But if it doesn't come up, you might end up with messages like this: invalid MD5 digest. Well, they probably typed in the wrong password. Maybe they typed in Cisco with a 0 rather than Cisco with an O. Okay, you shouldn't use Cisco as a password, but you get the general idea. But the things like that, zeros and O's can be confused with each other, I's and ones, L's and ones, and so forth. 8s and B's, all very simple to confuse. And these are often causes of problems like this. Some people generate random strings and use those for passwords in BGP sessions. And in the few that I've been involved with, yeah, well, it's nice to get a random string, but, well, It can lead to even more mistakes as you try and transcribe this string from the email or however you received it onto the actual router configuration. But look for the router to help you. It will tell you messages like this, invalid MD5 digest, if somebody's got the password wrong somewhere. Okay, so once you fix the password, then the peering should just come up. So common problems can be missing a password. Both ends actually need to have it. Cut and paste errors. Cut and paste is generally a pretty bad idea, but again, you'll be amazed how many people do it. Typographical errors, transcription errors, so confusing the different characters, putting white space in the password. That used to be a problem. Thankfully, it's now gone, but it used to be an issue. Extra characters, double hitting a keyboard by accident, so forth. But look at the log messages, because they'll give you wonderful hints. What about flapping peers? Well, common symptom can be an eBGP session establishing, and then it sort of starts, maybe a few prefixes, then it just stops. And you expect to get 210,000 prefixes from your neighbor, and you only get 2. So what's going on? So it falls over, picks up again, same thing, falls over, and so forth. And these are generally caused by infrastructure problems between you and your remote peer. Make sure logging is enabled. No logs, you've got no clue what's going on. It really is as simple as that. If R1 and R2 are peering over some third-party layer 2 network, which, well, is probably more common in the past, less common these days, but still happens in parts of the world, then, well, you really need to look hard at what that layer 2 network is doing. The typical messages you see are those on the screen, where you got notifications sent, and this notification is actually hold time expired. Hold time is generally 3 times longer than the keep alive interval. Well, it certainly is in iOS, 3 times longer than the keep alive interval. For keep alive is 60 seconds, then the hold time is 3 minutes. So if the peering just does this 3-minute cycle, then you can suspect that there's some problem. So you're not getting the keep alives from the other side. And so you then have to go and find out why you aren't. Why are the keep alives disappearing? Well, the clues are really in the BGP summary. Have a look at the number of messages sent. Messages received can be helpful, but especially the queues, the BGP in queue and the BGP out queue. If you think of BGP as 2 processes, a sort of in process and an out process, well, the out queue really lists how many updates are waiting to be sent out in the out process. So we've got 97 updates sitting waiting. We've now got 98 updates sitting waiting. The problem is that the hellos are stuck in the out queue behind the update packets. You now have got to try and work out why the update packets aren't being sent out to the neighbor, especially if you see this incrementing counter and then the peering session falls over. And then it reestablishes, and then you get an incrementing out queue, and then it falls over again. It's very, very symptomatic of a big layer 2 problem. And here a simple tool like ping can help you. We just do a ping to the neighbor, and well, we get a nice response. Well, that's fine, but standard ping packets are only 100 bytes. Network can handle 1,500 byte packets, so let's try and do a 1,500 byte ping. Well, nothing gets through at all. And that's where you can start suspecting MTU problems in the network. So what do you do then? Well, just try varying sizes of ping packets until you see what can actually get through or what actually ends up being blocked. And you can just do a nice binary search through this range between 100 and 1,500. And you can figure out what you can send through and then what you can't. And once you work out what gets blocked, then you can speak to your L2 folks and say, well, why are you filtering all packets more than 1,200 bytes long? And then you can enter that particular merry-go-round there. As I said at the second bullet, try and be helpful. I mean, try and say to them, well, you know, I can send 1,200 byte packets, but 1201 byte packets get blocked. So something's filtering on the 1,200 byte boundary. Go find out what it is. It could be hardware, it could be software, or so forth. Okay? You don't just sort of sit there and say, well, it doesn't work, go fix. Because the layer 2 folks understand layer 2 stuff, and they don't really understand any BGP things. Other causes of flapping peers, well, it can be the remote router rebooting continually, typically with a 3 to 5 minute BGP peer cycle time. 3 minutes is generally, you have MTU problems. If it's going to be between 3 and 5 minutes, then it's probably the remote router rebooting. Well, it just depends what the remote router is, because some take a lot longer than 3 or 4 minutes to actually boot. But that can be a general hint of what could be going wrong. Or it could be the remote router BGP process is unstable and it restarts. They might have something like a maximum prefix thing set. And then when you hit the maximum prefixes, it pulls the BGP session down and then it brings it back up again. Could be traffic shaping. Yes, I kid you not. People actually do traffic shaping and it includes BGP sessions. I've had a few ISPs who do that because they believe that buying rate limiting boxes is the best way of doing quality of service for their customers. Only they forget to exclude BGP from this. And so when BGP is sending a major amount of updates, well, the rate limiter kicks in and says, nope, we're not going to send all these, throw away. MTU incorrectly set on the links, path MTU discovery is disabled on routers, all these things can cause flapping peer problems. For non-ATM or frame relay connections, it can be instability in layer 2 point-to-point circuits, faulty muxes, bad connectors, interoperability problems, PPP problems, satellite, radio, weather, and so forth. All the typical layer 2 problems can interfere with how BGP actually works. But the only tool you really need to use here is ping. I mean, ping is actually pretty useful, especially with the different range of sizes that you can use. Anyway, so you've now fixed whatever the issue is, any of the ones that I mentioned before, so the BGP session is now stable. What about missing routes? And no, it is not a bug. I mean, how often have I had these emails? Oh, well, I've set this up, and well, some of the routes are missing. What's going on? Is it a bug in iOS? Well, probably not. Those days should be long gone. Once the session has been established, updates are exchanged, and you've got all the locally known routes, only the best path is advertised to BGP neighbors. Once you've got all the exchange happened, all you should have after that are update messages. So any changes in the BGP table will be sent by update messages. Best path is received from eBGP peers. That's advertised to all peers, whether internal or external. If the best path is received from an iBGP peer, it will be advertised only to eBGP peers. Okay? We assume that a full mesh iBGP exists, or at least the alternative to the full mesh, which is route reflector or confederation if you're still using those. But generally, we assume that full mesh iBGP exists. But I'm going to look at something a bit later on, because you can have problems with iBGP as well. And you'd think they are non-obvious no-brainers, but actually, with some of the larger networks out there still trying to maintain large iBGP meshes, you can have lots of interesting problems too. So, the missing routes, well, the route origination problem. Well, the common problem occurs when you're trying to put prefixes into the BGP table. And still some people have this difficulty of understanding that the BGP table is not the RIB. Yes, BGP has a RIB, but it's its own one. It is not the actual master router RIB. Okay, the RIB is the routing information base, or what most of us these days call the routing table. BGP table is separate. OSPF link state database is separate. ISIS has its own table as well. Static routes have their own place, and so forth. All these are used to feed the RIB. And the RIB, of course, is then used to generate the FIB. The FIB is the forwarding information base, and that's what generally goes on to forwarding engines in the routers. The other thing is, each routing protocol has a different priority. Okay? Again, it depends on who your vendor is, but for example, in Cisco case, BGP priority is 200, whereas OSPF priority is 110. Static routes priority 1. Connected routes priority 0. Lowest priority wins. It's amazing how many people actually either don't know this or completely forget this. And it's like, well, this is in BGP, but it's not being advertised anywhere. Well, hang about, because it's in OSPF too. So have to be aware of some of these kind of issues even before you start doing the troubleshooting. To get a prefix into BGP, it has to exist in another process also. So typically in iOS, you have a static route pointing to a customer. For customer routes, you put into your iBGP, or static route pointing to null for aggregates that you want to put into your eBGP. Another little pet rant of mine, which I generally direct more at newcomers to BGP in the emerging areas of the internet, is iBGP is not eBGP. Okay, they actually are two completely separate things well, they are related because they share the same name. Both use the word BGP, but they actually have completely different behavior characteristics and are used for different things. But it has to exist, a prefix has to exist in another routing protocol before it will be actually announced by BGP. So if you don't have a RIB entry for the prefix you want to advertise by BGP, BGP is not going to advertise it. So I've probably been too aggressive in cutting out configuration snippets here. But this is a BGP network statement. In iOS, the BGP network statement simply says, if you see this prefix in the routing table somewhere, put it into BGP as well and announce it by BGP. It doesn't actually put the prefix into BGP if it doesn't exist anywhere else. If you don't have a static route, then, well, you just don't get the prefix announced at all. So no static route, then the network's not in the table. BGP will not announce the prefix anywhere. So what do you want to do? Try and nail down the routes you want to originate. And if it's an aggregate like this /22, then put a static route to the null interface. That's generally a best practice thing to do these days anyway, because if you have no more specific path than this, then that null interface will catch all the garbage that's going to be directed towards that particular address block. But aside from that, this will put an entry in the routing table into the RIB. Because the entry is now in the RIB, show IP route, whatever, you see it there via the null interface, BGP will now put the prefix into the BGP table. And that's a fairly common standard beginner BGP configuration. But yes, a lot of newcomers to this have great trouble with this particular concept. BGP is not announcing my prefix, I've done something wrong. Well, you've simply missed this little step out. What about generating the aggregate? Well, the aggregate address command has got one unique property. It will actually set the aggregator attribute in the announcement. And that's pretty much the only real use that it has. I generally try and prefer generating my aggregates by the static route and BGP network statement method. But you can also use the aggregate address command. The aggregate address command will only function if there is a component or sub-prefix of that address block in BGP. And that's actually why I don't use the aggregate address command, because I've been burnt by this far too often. If the component route is not there in the BGP table, then the aggregate will not be generated. And I can think of 3 or 4 occasions where my aggregate disappeared simply because a BGP sub-prefix disappeared. So you have to be kind of careful with this one. If you look at a component prefix of this network 7.7/16, you can put the longer keyword in there, and well, if there's nothing there, then you've got no sub-prefix, so the aggregate is not going to be generated. So what you do is you generate a component route, just stuff in a /32 or something. That's now a sub-prefix of that /16, and you'll see it in the BGP table there. The aggregate is generated as well as the component. The S, of course, you see at the start there, means the component is suppressed due to the summary-only argument that I used earlier for creating the aggregate address. So you can appreciate that there'll be some difficulties here, and that's a personal preference of mine is really not to try and use the aggregate address. All it does is generate an aggregator attribute, and I've never really been convinced of its use in real life. So just summary of all that. Network statement rules, you need the exact matching route in the RIB as well before BGP will introduce it. Aggregate address command looks into the BGP table. It does not look into the RIB. The longer keyword is pretty useful for the show IP route and show IP BGP because it shows sub-prefixes. So the show IP route will show prefixes in the RIB. The show IP BGP will look at the BGP table. They are different things. What about update issues? Well, update issues. Well, the favorite one these days is route reflectors. I always thought route reflector was the most wonderful solution that came along to try and help us scale iBGP. And I thought it was beautifully simple as well. And I've always considered, well, why on earth was this not thought about from day one? So I've led this fairly sort of simple belief thing that, oh, well, route reflectors are a great thing. And then, well, I joined Cisco after that and started having to go and help ISPs fix the networks and so forth. And you'd be amazed how complex and convoluted people can actually end up making route reflectors. I just wonder how they manage it. And they always seem to be able to break all the rules all of the time as well. And the common issues you see are clashing router IDs and the clashing cluster IDs. You've got two route reflector clusters like this. So router 1 is a route reflector serving router 3. Router 2 is a route reflector serving router 4. Router 4 is introducing a prefix into IBGP. Router 2 sees it, but router 1 and router 3 do not. And you go, well, why not? This should just work. 4 sends to 2. 2 is a route reflector. 4 is its client. 1 is a standard peer, so it should just be sending prefixes it learns from a client onto a standard peer. And router 1 should be taking anything it hears from a standard peer and passing it on to a client. So why is it not doing it? It's a bug. Well, it's not a bug. Firstly, you need to try and figure out how router 2 actually handled the prefix it heard from router 4. Did it send it to router 1? So we can do show IP BGP neighbors, advertised routes. It will tell us what we announce. And router 2 says, yep, I sent network 7/8, or whatever it was, towards router 1. So that's fine. So we look on router 1. Did it get it? No. Okay, it got lost on the wire somewhere in between. I mean, it's as though wires can somehow just lose prefixes in the middle. But I've had people claim that to me quite a lot. Well, we have a look at some of the debugs. And this is my first caveat, what I sort of hinted at earlier. Debug IP BGP is really not a wonderful idea without actually putting some kind of protection on it. So we set up an access list for the prefix we want to debug. And the prefix we want to debug is network 7. So we set up an access list with that, and we do the debug basically just for that network. And then we do a route refresh on the peering. So we get router 2 to resend their updates to router 1. Clear IP BGP on the router 1 address out, and we look at the logs that we get from debug. And it shows us some interesting things. So with router 1, what does it say? It receives an update, attribute this to the next hop, origin as IBGP, local preference 100 metric 0, originator 100 at 1.1.1, cluster list 2.2.2, path, community extended, and so forth. Next message, update denied due to originator is us. Okay, the reason the route reflector is denying this update is because it's got our originator ID. If we've already originated the prefix into BGP, then we don't need to hear the update. So this is just some BGP sanity checking. We don't want to hear updates that we've originated if they somehow got back to us. It's just simple loop detection, really. Okay, so router 1 is quite rightly throwing away the prefix because it sees its own router ID in the update. Because when these routers were deployed, well, router 1 and router 4 have the same router ID. And if they see our own router ID, we basically throw the prefix away. So the solution is very simple. Do not set the router ID by hand. Or should I say, do not set it by hand unless you really know what you're doing and you have a really good reason for doing so. The most important thing is a plan. If you're just going to randomly assign router IDs and just hope that you remember them all for the 500 routers you have in your network, then you're going to go badly wrong at some stage through the whole process. So it's generally not a wonderful idea to try and set the router ID by hand. Now, this is all probably vendor dependent. iOS will automatically set the router ID. Highest IP address in the box, or it will take the loopback interface address if that is set. But you're going to set a loopback interface address anyway because you're running IBGP between your loopbacks. So this should never be a problem. It'll only be a problem if you try and override the router ID by actually putting the configuration in manually. Second example, you've got one route reflector cluster, and you've got 2 route reflectors in that cluster. So R1 and R2 are the route reflectors, 3 and 4 are the clients. 4 is advertising that network, same deal as before. 2 can see it, 1 and 3 do not. So router 1 is cluster ID 10, router 2 is cluster ID 10. Okay, that's fair enough. There's certainly nothing bad with doing this. We look through the same steps as before. Did router 2 advertise it to router 1? Well, we look at the advertised prefixes, and sure enough it did, and sure enough router 1 did not get the prefix. Well, it says it doesn't have it anyway. Again, we do the debugs. Set up the access list. We send the route refresh to resend the updates. And router 1 shows us, again, something interesting because we're looking at the debug messages. Same kind of thing as before. We've got the next hop, originator, cluster list, and so forth. And then we see the second line, received update about network 7, denied due to reflected from the same cluster. We've got 2 route reflectors in the cluster. Again, we've got an efficiency here. If you've got 2 route reflectors in the cluster, then of course the clients need to speak to both route reflectors. You can't have some clients speaking to one route reflector and some clients speaking to the other route reflector and just assume the route reflectors are going to send prefixes between the 2 sets of clients. You can do that if there were different clusters, but if they're the same cluster, you can't do this. So you have to remember, all route reflector clients must peer with all route reflectors in the cluster. So if you've got 2 route reflectors in the cluster, your clients have to have BGP sessions with both of them. If you miss any out, even if you miss one out, you end up with this black hole kind of appearance. And this common symptom of this is, like, most of your customers are happy, apart from 1 or 2 who whinge that they can't reach a particular site on your backbone. And you can see this happen quite a lot, and as ISP goes into complete denial. Oh, you're running Windows or something that's all broken, or oh, it's your network, or maybe it's your router. You hear all this stuff, and it's like, well, have you actually looked at your iBGP? Have you looked at your route reflector setup? Okay, so router 1 is not accepting the route when R2 sends it because it sees its own router ID and the cluster ID attribute, and it will reject the prefix because it assumes that router 4 will have got an iBGP session with router 1 already, so it already has the information, so it doesn't need another update. So why did all this happen? Well, there's early documentation, I don't really know where it all came from, but there's early documentation that basically claimed that route reflector client redundancy or cluster redundancy should be achieved by dual route reflectors in the same cluster. I mean, in fact, when we deployed route reflectors first, back in our network, I think it was about 95, probably 96 we did it. We never even did this. And when we had a visit from systems engineer who was checking over our network as part of a contract, he said, ooh, you shouldn't be doing this, this is illegal. It's like, well, we've been using it for the last 6 months and it seems to work fine. So there's certainly a lot of early documentation that said that the only way to get redundancy for a route reflector cluster was to have 2 route reflectors. And the way to have 2 route reflectors in the same cluster was to set the cluster ID the same. But that's fine and good. And I always worry about, after this tutorial, after my multi-homing, the BGP techniques tutorial, people come and say, oh, but if you've said all these bad things about having route reflectors with the same cluster ID, but I've deployed this and I've had no problems. And it's like, well, fine, you've had no problems. When you've had to troubleshoot entire country backbones where there are 2 route reflectors and they're in different cities, but they've got the same cluster ID, and the whole network has partitioned and fallen apart, and it's become a serious critical national crisis, then you kind of start questioning why people blindly follow documentation without actually thinking what they're doing. My actual preferred solution is to have overlapping route reflector clusters. Clients can belong to more than one cluster. So you have one route reflector sitting in one cluster, and of course he sets his cluster ID automatically from the loopback interface address, and the clients can speak to a route reflector in another cluster, which has another cluster ID, which is set automatically. Okay, keep it simple. It's all kept nice and simple, and it all just works. People can't believe it when stuff is simple. They think that there's some catch somewhere, and there rarely is. Okay, so that's another common issue that I've come across, and I think it's worth highlighting. These are the 2 common problems that I see with route reflector deployments. So just some troubleshooting tips here. The show IP BGP neighbor advertise will generally tell you what you've sent to your peer. The routes in the next one will tell you what has made it in from your peer through your filters, and received will tell you what you've actually received from the peer, even if it didn't make it through your inbound filter. So that's just the subtle differences there in these particular troubleshooting commands. The soft configuration thing, well, this came around before route refresh was standardized, and I mean, I guess other implementations of BGP have something similar to this. It basically lets you refresh a BGP session without you having to send a message to your remote neighbor saying, hey, can you just resend me all your updates? And the way it works is by storing all the updates that come from the neighbor. So if you need to change your inbound filter policy and so forth, you just do a soft reconfiguration or soft refresh, and that will take all the prefixes, or at least all the updates that you've stored, and rerun them through your inbound filters. So for example, if you do a show IP BGP neighbor routes, this is what has actually made it through your filters in the first highlight here. So that's what's made it through your filters, but if you do a show IP BGP neighbor received, then you find out what's actually arrived from your neighbor. So I've done things like look at local preferences changed, and there's 169.254 prefix has been thrown away because it's one of the non-routable address blocks. Okay, so that's an example of what this can actually do for you. All right, filtering. Filtering can cause lots and lots of fun and games also. Types of filters we have, obviously, are prefix filters, AS path filters, community filters, and, well, again on iOS, route maps. And these can be applied inbound or outbound, or both, of course. The first bit, having a look at what can go wrong with filters. Well, you can determine which filters are being applied to a BGP session. You can do show IP BGP neighbors. You can do a show run, have a look at what the neighbor configuration is about. Have a look at the prefix that's giving you problems. Pick out particular attributes about it. Just doing show IP BGP will give you that. Compare the attributes against the filters to try and work out what issues might be. Having a look at some of the update issues, say router 2 is sending network 10/8 to router 1. So we're missing network 10/8 in router 1. Router 1 doesn't see it, but router 2 is sending it. Okay, so there's a router 1 output, show IP BGP neighbor routes, nothing. What's happening? Well, router 2 is originating it, or at least so they think, but it's not advertising it towards router 1. If we do show IP BGP neighbor advertised, there's nothing there. Yet, we see network 10 sitting in the BGP table. Okay, it's sitting there in the BGP table. 000 means that I have originated it. So what's happening? Well, it's time to actually go and check the filters. So let's have a look at what could be a problem with filters here. Well, we see the configuration appearing with router 1, neighbor 111, remote AS3, filter list 1 out. So we're applying an AS path filter outbound. Show IP AS path 1, okay. Show IP AS path 1, it says permit $, or $, whatever you want to call it. And that means permit basically anything originated by the local AS. It looks innocent enough to me, doesn't it? That should work. Anything originated by the local AS, network 10 is in the local AS, it should just go out. Got no prefix filters there, so this should work. Well, then I do show IP BGP filter list 1, and it's blank. I go, right, okay. Next slide, previous slide. IP AS path list 1 says permit $. But then I do show IP BGP filter list 1. That means I've taken the entire BGP table on the router and run it through AS path filter 1. I've got nothing. Okay. Show IP BGP regular expression, $. I get something. This is where you speak to your phone, your friendly local vendor representative and say, there's a bug here. Got to be a bug. But it's not. Okay? Try retyping the regular expression. Okay, you've typed it in here properly, that works. Previous slide, you've got it there in the configuration, that doesn't work. What's going on? Show IP BGP regular expression $. Nothing matches. So we've actually cut the configuration out of the fixed configuration in the router and dropped it into the command line here. And then we've got nothing matches. End of line, it's a white space afterwards. You've really got to try and watch the white spaces. I think this issue, certainly in most recent software, goes away now because white space is cut out from the end of the line. But for years and years, this was a fairly major issue, trailing white space. Of course, it's a valid match. And that would cause all sorts of regular expressions that looked right to the eye. They looked right to the eye, but it would cause them to fail. Okay, so that's one issue. So we force R2 to send update after the filter list is corrected. Then we see if R1 has the route. Clear IPBGP out. Show IPBGP network 10. Well, on router 1, it's not in the table. R1 still doesn't have it. We assume that nothing else can go wrong in router 2, so let's look at router 1. Well, router 1, we do a show run, include neighbor, whatever, and it says route map policy in. So we're going to apply some inbound policy to the announcements coming from router 2. And the route map is, oh, well, all kinds of stuff, but it's got here match IP address access list 100 and 101, and it matches AS path filter 1. That's all fine. Apart from me never really wanting to use access list for applying policy, because this is historical, but I'll show you really what can go wrong here. Show access list 100, permit IP host 10, blah, that's all fine. Access list 101, permit 201, blah, that's fine. AS path 1, permit hat 12. Yeah, I'm peering with neighbor 12, so that's fine too. Okay, so it's all fine. What did I do? Yeah. Okay, so what's happened? Have I lost a slide? No, I haven't. Okay, so the configuration looks all fine. Router 2 is sending it. Router 1 doesn't receive it. We need to try and run some debugs. So we set up an access list, again, to try and protect the command line for us doing the debug in the BGP. We don't want it to overrun, so we just set up an access list. We're only going to do the debug on network 10. Do a debug IBGP on this peering with updates run through access list 99. And what does it say? BGP, blah, blah, blah. Receive network 10/8 denied due to route map. Oh, okay, so the route map is blocking it. So there's something wrong with the route map. What on earth is it? Well, it's highlighted here, access list 100, permit IP host 10.0.0.0, host 255.255.0.0. It's a /16. We are trying to announce a /8. This is one of the real reasons I really dislike using an access list for filtering BGP sessions like this. Prefix lists, of course, have been around for several years, but people are still using access lists because, hey, well, that's what we used 10 years ago, and it's nothing really wrong with it, so we're not going to change. But this is one of the one of the issues that can actually crop up. The mask has been wrong. It's very, very easy to type 255 when you mean 0, or vice versa. And this happens an awful lot. But that line is actually blocking the announcement of network 10/8 coming in from the neighbor. So that's why the prefix isn't getting through. Okay, so I had the wrong mask there. So I need to fix the mask. In fact, it's a lot more sensible to use the prefix list, as I said there, because it's actually more difficult to make a mistake. What about the ACL 101? Well, multiple matches on the same line are actually OR together. Multiple matches on different lines are ANDed together. So the second line matching the AS path actually did work. And ACL 101 doesn't matter because ACL 100 already matched. Okay, so that's why this broke. So if you suspect a filtering problem, become familiar with the router tools to find out what the BGP filters are. Okay, really important, second hint, don't cut and paste. How often do I say it? How often do I see people do it? Cutting and pasting causes a huge number of problems. Many filtering errors and diagnosis problems result from cut and paste buffer problems on the client, the connection, or even the router, as I say there. So really try and work hard to avoid cutting and pasting wherever possible. Okay, what else? You can have typos and regular expressions, extra characters, missing characters, white space. As I was saying before, regular expressions have an importance that every single character is actually does matter. So you need to be accurate. If you're not accurate, then you can end up with weird things going on. Watch the prefix filters, especially watch the net mask confusion. 255 is very, very easy to type as 225 or 0. I've seen that an awful lot. Watch the router CLI, especially if you're heading into multi-vendor environments. There can be different interpretations of the same concept. So one person's idea of trying to do this filtering might be different on another implementation, even though they conceptually look much the same. Okay, so it may not be as obvious as you think, or as simple as the manual makes out. Community problems. Oh, yes, communities can cause all sorts of problems as well. This scenario, we'll just have to respin it, but trying to use communities instead. Again, router 1's not seeing the prefix. So router 2 is originating the prefix into the BGP table. Community is not set. If the community was set, it would actually be displayed in the BGP output. So we need to fix the configuration. Here's one way of doing it. We set the community just from our set community command. But basically, we'll put that prefix into community 2:2 or 1:50. Just an example. And then we do show IPBGP in the prefix. We see the community set down there at the bottom. So that's fine. So router 2 is now advertising the prefix with community to router 1, but router 1 is still not seeing the prefix. Usual thing is you get into the discussion with your peer and they say, yeah, I mean, it's nothing wrong with my configuration. It's perfect. It's all your mistake. Well, something's wrong somewhere. We've verified the configuration in router 2. There are no filters blocking the announcement, so what could be wrong? Well, we check router 2 configuration again. So we're setting the community, remote AS1, prefix list migrate out, prefix list there, aggregate in, prefix list is all fine, route map set community. Okay, looks good to me. But the forgotten one thing, forgotten neighbor, whatever, send community. iOS does not send communities anywhere by default. Not for iBGP, nor eBGP. Frequently forgotten thing. And this causes a lot of big problems in a lot of places. So you need to actually enable the peering so that you can send communities to the neighbor. Because if they're trying to do filtering just on communities and you don't send any, then they're just going to throw everything away. So you need to watch that one. So add that particular configuration in, and it should work. Router 1 still doesn't see it. Well, router 1's got IP community list 1 permit 150. So route map R2 in is here. It says match community 1, so we're matching this, set local preference 150. So if we see any prefixes coming in with community 1:150 set, we set local preference to 150. There's no second line here, so everything else is thrown away. And it's like, well, hang on, what were we actually sending? Well, we were sending 2:2 1:50. We're not sending community 1:150. See, an extra 1 has sneaked in there. So this is, again, something to watch. Again, a frequent occurrence. Maybe missing digits in the communities being set. Get the AS numbers wrong, or you get numbers swapped around and so forth. These are all issues that are frequent issues or frequent problems. Okay, so the community is actually wrong. R1 is expecting 1:150 to be set, but R2 is sending this. So who made the mistake? Well, somebody did, whether it's the operator in R2 or the operator in R1. The community does not have, sorry, prefix doesn't have that community set, it is dropped. There is no next step in the route map. You have to watch the route map rules in iOS. They're very strict. The default is to throw stuff away. So if there's not a match and you've got no explicit allow everything, then well, all the other updates will be thrown away. So the rule set is basically this. So you fix the configuration R2 to set the community to 150 on announcements to R1, and then it should all work fine. Fix the configuration R1 to permit prefixes not matching the route map, because it makes troubleshooting easier. And we should be set. So we do show run, beginning with the route map, so we've got R2 in, match community 1, set local preference 150, R2 in, basically there's no match line there, there's no set line, it just means we match everything and do nothing else to the prefix. We look in R1 and we see the entry there for network 10. So that's good. So just the caveats, watch route maps, watch the route map rules especially when they're used for filtering prefixes. Those more advanced BGP practitioners quite often will use route map for filtering prefixes as well as applying other policies. Generally, when I'm starting off, people in the BGP road, it's, well, use prefix lists to filter prefixes, the AS path lists to filter AS paths, and route maps simply to manipulate BGP attributes. Once you've figured all that out and you're comfortable with it, then you can start using route maps to start filtering prefixes. It's people who plunge into using route maps for everything right from the start can end up with a fairly serious mess. Remember to configure all routers to send BGP communities. My personal preference is to send communities for all IBGP speakers. I think it's certainly on the Project Gumri template, and for IBGP template, you've got the send community set there. I'm pretty sure other BGP implementations will send communities by default for IBGP. Some will even send it by default for eBGP, but I'm not particularly convinced about that. A community being used for eBGP has a very different intention than for a community being used for IBGP. And I'm not wildly comfortable leaking internal communities out to the outside world. Just a personal preference. So, as I say, each router implementation has different defaults for when communities are sent. Be aware that iOS does not send communities unless you explicitly say so. Each ISP's got different community policies as well. This is a classic case of where somebody may send a no export community on a prefix towards the neighbor. But if the neighbor doesn't support any communities whatsoever, then your no export is lost, and your prefix that you never intended for anybody else to see starts wandering around the globe. So never assume that just because they exist that people will actually use them. If you want to use communities for your eBGP session, make sure your eBGP peer will actually support them, will actually do something with them. Okay. General problems, make and then stick to simple policy rules. Most router implementations have particular rules for filtering of prefixes, AS paths, and manipulating attributes. Try not to mix them, especially if you're fairly new to this. Rules for manipulating attributes can also be used for filtering prefixes and AS numbers. As I said earlier, they can be very powerful. You can see some really amazing configurations. You can look at some of the bigger ISPs. You can produce amazing configurations if you use the Internet Routing Registry, for example, to generate configurations for you via the IRR toolset. But they can end up being very, very confusing to the layman because it ends up more looking like obfuscated Perl or C or something rather than simple human-readable configuration. So you really have to try and watch things, try and keep things as simple as possible. Okay, next bit, IBGP mesh problems. Or as sometimes I say when I'm speaking too fast, IBGP mess problems, because it pretty much ends up being the same thing. First example I want to look at is, well, this one. You've got prefixes seen across a network, but there's no connectivity across that actual network. Or there's problematic connectivity. Prefixes learned from an eBGP peer are passed on across the IBGP mesh, but you've got no actual prefixes or connectivity to those prefixes. So something weird going on. So router 3 customers, so router 3 is sitting there connecting towards AS2. Router 3 customers can reach AS2, but no other customers connected to AS1 or AS3 can reach AS2. Okay, so everybody connected here can reach AS2, but nobody else can reach AS2. So what will be happening there? Well, let's look on router 3. Look what the BGP table says. Look on router 3. We've got a nice BGP table. There's the next hop. Here's some paths. There's some prefixes. Yeah, life looks rosy. And they've all got the little arrow sign there, so it means, yes, it's all the best path. Great. Let's look on router 4. Well, router 4 is just another router within the AS1 network. What does router 4 see? We never just jump onto one router and then base your assumption on that. Have a look at another router in the network. Again, when you're trying to do this in real life, you get a full appreciation of why this is important. Look at another router in the network and see what it thinks of things. Well, you see the same BGP table, but there's one difference. The arrows have all gone. There's no best path. Okay? This is the only path towards this destination, but it's not the best path. So BGP has decided that in the best path selection process, this is not a suitable path. Why not? Okay, that's generally just what I said. Valid and best path, valid internal, but it's no best path. And that's the clue. Or if you only see one path to destination, but no best path, start suspecting something about the BGP path selection process. So we look at the BGP table entry, show IP BGP network 10.10.00. Well, BGP 10, let me see, it says no best path. And network 10.10.10.10 is inaccessible. Well, 10.10.10, if you remember, let's just go back. 10.10.10 is the next hop. We're looking at network 10.10/24. That is the next hop. And it says the next hop is inaccessible. Well, you remember what item 1 of the BGP path selection process is, if you, well, like reading up on these things and memorizing them. Item 1 is, if there's no valid path to the next hop, don't consider the path. Okay, bingo, that's what's happened. Look at the routing table entry. Network 10.10/24, network not in table. Show IP route to the next hop, network not in table. Well, if we can't get to the next hop, why on earth would we try and use this as a path? So that's why router 4 doesn't use any of these, or doesn't think any of these prefixes are the best path. So, what next? What's actually happened? Well, there's something broken on router 3. Either router 3's got no routing information how to reach the 10.10.10.10 point-to-point link, but forgetting to put the link into the IBGP, or they've not excluded external next hops from the internal network, probably because they've forgotten to set next hop self for all externally learned prefixes in the IBGP session. I mean, there's a general rule in designing IGP within a network, so IGP as an OSPF or ISIs. You don't particularly want to carry your external point-to-point link addresses around in your IGP. If you've got 10,000 customers, that means you've got 10,000/30 point-to-point links. 10,000 prefixes in your OSPF, 10,000 prefixes or 10,000 reasons to make your OSPF or ISIs go slower. So what a lot of ISPs do is, rather than carrying these point-to-point links around in OSPF, they use something called next hop self in IBGP. And what this does, it will change the next hop from the external neighbor address to the address of the local router, in other words, a local IBGP speaker. So it'll change the next hop address to be that of the local router, because the local router knows how to get to the external neighbor. That's all that really matters. And that saves carrying all of these point-to-point links around in your IGP. But quite often people will not carry the point-to-point links around in the IGP to do the saving, but then they forget to do the next hop self command. Or they're quite happy carrying the point-to-point links around in the IGP, they just forget to do it. So those are the two issues, and those are the very, very common issues for a lot of BGP deployments that I've seen. Okay? You have to be able to reach the next hop, otherwise BGP won't use it. So make sure that all the next hops are known by the IGP, whether using ISIS or OSPF or static routes or connected routes. Doesn't matter, as long as it's something, apart from BGP, of course. If the next hop is also in IBGP, ensure the IBGP distance is longer than the IGP distance. That can catch people out too. Or, better still, don't carry the external next hops in the network at all. Replace the eBGP next hop with a local router address on all the edge BGP routers. So that's the iOS command next hop self. If you're not using Cisco's, your own implementation will have something very, very similar to this. So, R3, we've now got the missing next hop self configuration, and well, look what's happened. Router 4 now sees these 4 prefixes as best paths, and that's what you should be seeing throughout all the routers within your IBGP. It's actually quite fun sitting through a workshop class with people sort of trying to bring up IBGP sessions, and they say to me, yep, I'm all finished, all done, I've got all my prefixes there. Well, can you reach any of them? Oh, do I have to do that? Well, imagine you're a real ISP with customers, and your customer entries all in your BGP table, and you're happy with that, yet they can't reach anybody. What do you say to them? Do you tell them it's their problem when it's your misconfiguration? Oh, well, but what do I have to do? Well, and so on. So it's a fairly fundamental thing that's missed out quite a lot. Okay, second IBGP problem can be this one. Customer complains about patchy internet access. You can access some but not all sites connected to the backbone, your own backbone. You can access some but not all of the internet. That's a classic one. They phone in and say, well, you know, I can access this and that, but I can't access them. And then, you know, the help desk response is, oh, well, you know what the internet's like. You know, some days it's not very reliable. Well, I mean, it was almost the reaction I had yesterday when I was trying to access something in Australia, and it was like, well, there was something broken somewhere. And the people I was speaking to at the other end said, yeah, nothing wrong in our network, nothing at all. And today I found out it was actually something wrong with the web server that was hosting the system I was trying to reach. But oh, no, it's something else. It's upstream ISP. They've got the problem. Okay, before you go blaming other people for things that are broken, check that your own house is in order first. And this is a classic one because, you know, it's not at all obvious to start, where customer complains that some things work and other things don't. And some of it's in your backbone and other parts of it are elsewhere. And these can all be down to IBGP. So we'll put it in the context of a picture. Customer connected to R1. So customer connected here. He can see AS3, so he gets in there just fine, but he can't get in AS2. Okay? He also complains he can't get to anybody in router 5 who's connected to router 5. But nobody else is complaining. So you can say, oh, well, you know, you're just a bad customer. You complain all the time. Or it could be something wrong with your router, or something wrong with your network, or maybe it's the link, or anything like that. I've seen all these excuses being used. Anything to sort of push the problem away to somebody else. Well, you need to have a look at that. So what do they say? R1 can't see anybody in R5. R1 can't see AS2. Well, I'd say this is a classic IBGP mesh problem. The full mesh is not complete. Okay, customers in R1, he can't see AS2. So that means that R3 is somehow not passing routing information about AS2 to router 1. He can't see R5 customers at all, which means that R5 is somehow not passing routing information about sites connected to R5. Well, that would be a logical first step, anyway. But he can see the rest of the internet. I mean, he can get to AS2 fine, so connectivity there must be okay. He can get to other routers in the backbone, so that's probably fine too. So it's an IBGP mesh issue. Okay, so his prefix is being announced some places, but not other places. So let's have a look. We jump onto R3, we do a show IP BGP summary, and well, what do we see? We see router 1, 2, 4, 5 as neighbors. Obviously, we're not going to see ourselves, router 3 as a neighbor. And well, we're all IBGP AS1, and we say, haha, router 1, state active. Interesting. That's been down. And look at this. BGP sessions have been up for 3 days and 16 hours. This one says, well, it's active. It means it's been down for 3 days and 10 hours. So it came up for 6 hours. Then somebody logged in, did something, and it shut it down ever since. So what's going on? Something's got broken between router 1 and router 3. So let's go and have a look at router 1. And we'll look at router 1, and you know they've done all the configuration template nice things. They've set up the peer group and so forth. They've got their update source loopback 0, and they're sending the community like they should. And they've got an IBGP prefix filter as well, just to keep things tidy. Neighbor, router 2, router 4, router 5. Wait a minute, where's the peering with router 3? Okay, where's the peering with 3? We've got 2, 4, and 5. Where's 3 gone? Somebody lost a line. Now, they could have just deleted it by accident, or they could have just missed it out. Okay, this case, it's hard to see why anybody would miss it out. If you imagine you've got like 20 routers trying to maintain 19 IBGP sessions, and when the numbers are incrementing, it's pretty easy to miss them out. If you don't believe me, try it sometime, and it's quite easy to miss it out. So we put the line back in. Router 3, it's now up. Okay, it came back up, and we've now got 8 prefixes, and so the customer should be able now to, connected to router 3, should be able to see Anybody connected to router 1, thereby it was AS2, I think. Okay. Now, second bit, BGP summary shows that no prefix is being heard from router 5. Remember we were saying that you couldn't see any customers from router 5? Well, router 5 is there, 0 prefixes received. There's the clue. So, are there inbound filters on router 3? Outbound filters on router 5? Well, we have no inbound filters on router 3, so it must be outbound filters on 5. So let's look at 5. Show configuration, beginning with, well, router 3 neighbor. It says remote AS1, update source, loopback 0, prefix list, eBGP filters out. Neighbor 4, router 4, remote AS1, prefix list, iBGP filters out. Prefix list, eBGP is this, iBGP is that. Simple typo. Okay, we've typed in the wrong name of the prefix filter. And this again can happen quite a lot. Some people just use very basic, boring names for prefix filters. They call them things like A1, A2, A3. And it's easy to mix up the numbers, especially if they're not descriptive. Here's typed in E rather than I. Okay, we've called it eBGP filter rather than iBGP filter. Or he might have typed in the name of something here that doesn't exist. He might have just called it BGP filters out. If the prefix filter doesn't exist, no prefixes get out. Okay? So that's the problem here. We're actually, the filter's only allowing network 20. We're trying to send network 10 by iBGP. And that's why we see nothing on router 3. Okay? Simple mistakes like that. So it's a very simple typo here. It's actually another advantage of trying to use peer groups. I mean, notice this configuration doesn't have peer groups or, well, peer templates or any other template system that you're comfortable using. Always try and do things that keeps the router configuration as straightforward as possible. So that means using templates and so forth. Then at least you make one change in one place and you can apply it everywhere with consistency. Okay, so we fix the prefix list on router 5. We check the iBGP again on router 3. Peering with router 1 is up. Peering with router 5, we see the prefixes. We confirm that this is all okay with the customer. Customers are happy again. And no, he wasn't being an awkward customer. There was actually just some breakage in your network. Now, this was a simple example. It was a simple example with just, well, 5 routers in the BGP mesh. It would be unusual for you to make a mistake here. But networks these days are pretty large, 20, 30, 50, 100, 200, 500 routers. I wouldn't suggest that there are 500 routers in a full mesh. But certainly when you've got a large number of routers you're trying to maintain, whether it's by route reflector or by standard iBGP mesh, it can get easier and easier to make mistakes with the more internal neighbors that you have. And the common mistakes are just the simple ones, missing out a peer. Okay, if you're running a full mesh with 50 routers in the network, which, that's not impossible these days, well, how do you go and deploy the next router? Router number 51. Well, it means you've got to, I've seen many people do it. They log into 50 routers and type in the configuration for that extra neighbor. Okay, the first one you do, it's fun. The 10th one you do, it's starting to get a bit of work. 20th one, well, you go away, have a cup of coffee, because it's starting getting hard on the fingers. By the 40th one, it's like, well, maybe go out for some lunch. And then you come back and you forget what you're doing because somebody phones you up and wants you to do something else. So you miss things out. Okay? I mean, it's all pointed towards a more automated system of trying to do your router configurations, a better way of trying to scale your iBGPs using the route reflector system, and so forth. Getting away from things that involve a lot of drudgery to put your configurations together. So watch the iBGP full mesh. Try and use things like peer groups and so forth. Try and use route reflectors as much as possible. Use confederations if you're using confederations. Just to try and avoid accidentally missing the iBGP peers. Another one to watch, of course, is the next hop for external paths. You can use the next hop self concept if you have it. Otherwise, make sure you carry the external next hop around such that it's reachable. So what I want to cover now is the inconsistent route selection problem. This is basically an issue where it just seems as though the router has made some kind of mistake or some kind of bad decision in the path selection process. And well, as I always keep saying to folks wherever I go, routers are dumb. They're just computers. They do what they're told. So they can't make mistakes. It's the people who program them who have made mistakes, or it's the program that's wrong. They're just blindly following what the program says. The two common problems you can get with route selection. The first one is inconsistency, and the second one is the appearance of an incorrect decision. Now, RFC 1771 was the original BGP spec. It's now obsolete, but pretty much anybody who's implemented BGP over the last 10 years has followed RFC 1771 to some greater or lesser extent. Every vendor has tweaked the algorithm. Because I suppose every vendor has learned by experience that if you implement it according to RFC 1771, it doesn't actually work too well in real life. You have to put in various tweaks and knobs and bells and whistles that your customers want, or for consistency with what other implementations have done. But then again, where there are gray areas, people have chosen different shades of gray, and these different shades of gray can cause problems. Or more formally, route selection problems can result from oversights in the RFC. We can't really blame the RFC for this. I mean, come on, it was only around with, what, one or two other BGP implementations and an internet routing table of probably 1,000 prefixes, if that. We're sitting here today with 210,000 prefixes in the BGP table, 24,500 autonomous systems visible from my view of the internet anyway. And that's quite a different internet from when RFC 1771 was first conceived. Anyway, the RFC is now obsoleted by RFC 4271, which has basically brought everything up to date. And I hope that if people are compliant with 4271, it should help avoid future issues. Forever the optimist. Anyway, RFC 1771 said that the MED is not always compared. And it pretty much left it at that. And it's, okay, so what does this actually mean and what do you do? Well, as a result of this, the ordering of the paths can actually affect the decision process. For example, the default in iOS is basically to store the order of prefixes in the order of arrival. So first in, first out. The oldest basically is the bottom of the pile, and the most recent is the top of the pile. And that can result in inconsistent route selection, because obviously you do your path selection based on the order the prefixes are stored. So the newest prefix comes at the top of the heap, the oldest is at the bottom. And if the oldest disappears from the table and then reappears a few minutes later, it then goes to the top of the heap. And then you get a path selection running on that, and might have a different result. And you normally think, well, this is not much of an issue, because the average internet BGP using network will probably have two external connections, one to each upstream, or maybe they have 3 or 4, maybe one to an exchange point and two to different upstreams. But in the center of the internet, you're looking at ISPs who've got multiple connections to each other, 10, 15, 20 connections to each other. And they probably spend a fair bit of time trying to do the load balancing over these multiple links. So when they take down one link for maintenance, and then they bring it back up again, and they get a completely different result for the load balancing, it can be pretty annoying. In fact, pretty awkward. So this actually causes a problem. It can cause things like routing loops, convergence loops, so the protocol is continuously sending update in an attempt to try and converge. Changes traffic patterns, which was the most serious one that was facing people. And when you haven't seen this before, it can actually be really difficult to handle. Difficult one to catch, difficult one to troubleshoot. I mean, once it's bitten you for the first time, then, well, you recognize it, and then, yeah, you can recognize it very easily. And in fact, so much so that, well, we had to introduce this thing called deterministic MED configuration commands, so that the paths would be ordered consistently. So no matter the age of the path, they would always appear in the same order when the path selection process had to run. And that way, the big ISPs with the multiple interconnections knew that if they did maintenance on any one particular link, that link would disappear from the BGP table, obviously, but when it was reintroduced, the link would come back, and that path would come back at the same priority that it was before the link went down. That's consistency. So the deterministic MED command is actually the one that is used here. I don't know what other implementations are like. Maybe they had or have had this consistent thing in because they're newer implementations. But iOS, the original one was pretty much per spec. Well, you just store the prefixes you come in, you do the best path selection on them, and, well, that's it. This is what it could look like. Slightly complex picture, but hopefully you can see how it's all working. We've got AS2 sitting here. So AS2, we've got one path through AS3 to get to AS10, and we've got another path directly through AS1 to get to AS10. And the symptom that you see here is that the best path can either be through this way, or it can be through that way. And which way it goes simply depends on the day, the time, maybe the phase of the moon, or maybe the weather outside. And this is not really a very good way if you're trying to do load balancing on two connections to reach another network. Router A sitting here has got 3 paths. So MADs that are sent by AS3 will not be compared with MADs from AS1. So certainly A sitting here will compare MADs that are here from router 2 and router 3. That's fair enough. We're not comparing any MADs here because they're from the different AS. And as I said, what you see is that router A will sometimes select the path from router 1 as the best path, and sometimes the path from router 3 is the best path. And it just oscillates back and forth depending on how you do your maintenance work. So we'll look at router A. Just show IP BGP for network 10. That's coming from AS10. And we see the 3 paths. So the first path is origin 10. It's heard from AS3, heard from AS3. Metric 20 this way, metric 30 that way. So the metric 20 is from router 2. The metric 30 is from router 3. And this one here is origin, well, AS10, heard from AS1. This is the best path. Okay, so why have we picked this one as the best path? Well, this one, pardon me, this one beats this one because that's the best path. And then this best path is compared with that one. Well, this one beats this one because we've got a lower router ID. 1.1.1.1 is lower than 2.2.2.2. And well, if you remember from path selection, once you get into router ID comparison land, things are getting really scary. You don't really want to go this far. So we already have ended up with a scary situation. Okay, so the best path in this case is path 3 because of lowest router ID. Okay. So we do maintenance on the link that's going through AS1. We shut it down, it disappears from the table. Sometime later, we bring the link back up, it reappears, and it appears at the top of the list because it's newest. So what happens with the comparison this time? Well, the router just compares 1 with 2, which is best. Well, comparing 1 and this one, well, we look at these. We can't compare metrics because it's different ASs, so it's down to router ID again because everything else is the same. Okay, so this one wins. 1.1.1 beats 2.2.2. And then so we compare this path with that one. Well, if you remember from the path selection process, external beats internal. So this one wins. Okay, because everything else is pretty much the same. Metric is lower down the path selection. External comes versus internal comes higher up. This is an external path, hot potato out to the network rather than going over our own backbone. So the best path now after performing the maintenance on the AS1 link is now through the AS30. Sorry, the AS3, the metric 30 path. All right. So this is not good. The best path is different simply because we've done maintenance on a link. If we switch on deterministic MED, we make a change. What happens here, rather than sorting the paths by the age they've arrived on the router, we sort them by neighboring AS. Okay, because that's always going to be the same. We just sort them by neighboring AS. So the best path for each neighbor AS group is then selected. So everything we hear from AS1, we do the best path on that. Everything here from AS3, we do the best path on that. And then we compare those. And the overall best path results from comparing the winners of each group are then used. And this one will always be consistent because it doesn't matter where in the list the paths appear. You'll always get the same result. So we look at the table now with deterministic MED switched on. So we order them by AS path, so AS1 obviously is the lowest number you can use. So that appears here first. So this is the winner of this one because, well, it's the only one from AS1. What's the winner from from the AS3 path? Well, we end up comparing MEDs, okay, because MED is, do we compare MED? Yes, we compare MED. Metric is 20 versus metric of 30. Okay, so metric 20 wins. So this path wins. We then compare these two, winner of this one with the winner of that one, which itself, so it's no contest. Well, this becomes the best path. Again, unfortunately, because we've got the lowest router ID. But at least wherever maintenance, whatever link we do maintenance on, we'll be assured that that will be the best path once we return to stability. So you've now got a stable connection to get out of your network. So that's what deterministic MED does. If you've got multiple external links from your network, my personal recommendation, I think it's now also a good practice guide, certainly on the Project Cymru template list, as well as Cisco's own documentation, is to set this deterministic MED on all your BGP sessions. I certainly encourage it, and it means that you will always get the same result every time you do any maintenance on your external BGP links. So as I was saying, use deterministic MED, enable it throughout the entire network. It's pretty easy just to add it into your BGP templates, and then you'll be fine. So the result of that will always be the same, just showing it in the picture. Router A's got the 3 paths. It will consistently select the best path through AS1 and router 1 to get towards AS10. Okay, what about this example? Best path changes every time the peering is reset. Well, you know, you've got router 3 sitting here. Best path can be this way. We'll reset the peering, then the best path is that way. Reset the peering, then it goes this way. Oscillates back and forth, and, well, it all looks pretty unpleasant. So, for example, in router 3, we look at the entry for network 7. It's originated by AS100. We hear it through network 10 and 20. Well, best path in this case, well, everything's compared, so it's pretty much done by age. Best path is the second entry there. Okay, we reset one of the sessions. We then swap them around. This now becomes the best entry. So the oldest external becomes the best path, because all the other attributes are the same. This was actually a stability enhancement that was asked for years and years ago. But what it can do, the stability enhancement, basically, it picks the oldest one. A stability enhancement that was asked for years ago and was included years ago. But the downside is you then get your best path always jumping around between externals. And some people, again, don't like this. They want the best path to be the same no matter what maintenance they do. So the solution to that was include the compare router ID thing, which again brings it back to the router ID comparison. And that was added a bit afterwards, after a few problems. I'm trying to remember when this was actually introduced, but probably about 12.0 must have been about, I don't know, 95 or 96 or something like that. It first appeared. Anyway, it doesn't matter. But it was a pretty much serious issue then with this jumping around between the external paths. Third example here. You've got this one. You look at the prefix. You see 2 paths. You've got this particular one, local pref 120. Internal path, you've got this one here, external path, local pref 100. Well, you remember from your path selection process, local pref beats everything pretty much. You look at this and you just go, well, hang on, local pref beats everything, so why has this one become the best path if we've got local pref 120 here? Ah yes, must be a bug. But no, this is actually, well, I suppose a Cisco feature that's just been hanging around far too long in the routers called synchronization. The default for iOS for years and years and years, and finally, thankfully, it's gone, is something called synchronization, where BGP will only announce a prefix if it was also known in an IGP. In other words, the IGP was synchronized with the BGP. Well, in the real world, nobody really needs this to be the case. I mean, it was probably okay when there were 1,000 prefixes in the internet routing table, but these days with 200,000 or 210,000, you really don't want to have 210,000 prefixes in your IGP as well. So synchronization is really a bit of a stupidity that should have gone long ago. But it can be caused by synchronization. And because synchronization hasn't been disabled, then, well, the router's going to look in IGP. And of course, if it's still enabled, it's not in the IGP, then BGP is not going to actually use the path because it's not synchronized with the IGP. So this actually was right. It was just purely operator error, not knowing that it had to disable this synchronization thing. But thankfully, all this can kind of disappear now. I'll come back to the synchronization thing, I think, a bit later on. Summary of this, RFC 1771, it wasn't exactly perfect when it came to path selection, but given lack of information and lack of operational experience in a complex internet, it was understandable. So vendors, as well as the service providers who've been using BGP, have been working together over the years to put stability enhancements into BGP, and a lot of these are now reflected in the updated RFC. 4271 replaces 1771 completely. Can lead to some interesting problems. Some of the defaults linger far longer than they ought to. So never assume that an out-of-box default configuration is perfect for your network. If you look at a big vendor, they're trying to sell equipment to every single industry. And some industries do not need the features that we need in the ISP industry. And I have that difficulty trying to sell ISP features within their own company. It's like, well, ISPs need this. Well, so what? That's 35% or whatever of the business. What about the other 65%? If we do this for ISPs, then it's going to break, however many other networks that are far bigger or more valuable, blah, whatever. So it's a very, very difficult balance to try and maintain. And the default, it tends to be touch as little as possible and make extra knobs available to satisfy the needs of a particular market. And actually, this is where things like the BGP templates that Project Kumri have put together, and what I've done in the past in the iOS Essentials stuff, have actually been pretty helpful to point folks to, well, okay, out of the box it does this, but this is what you want if you're going to use the router on an ISP backbone. Okay, next one, loops and convergence issues. Looping and convergence problems is one of the most common problems that you can hit. This one I'm going to describe is probably more peculiar to Cisco than peculiar to anybody else. If you've never really come across a Cisco network, and because you've lived in some other vendor space all your life, and then you come across this, it can be pretty startling to try and troubleshoot this one. And this one is pretty common, and if you don't recognize and don't know what causes it, you'll spend weeks beating your head against a brick wall trying to work out what's wrong. And if you only got a few prefixes in your network or in your BGP, you're not really going to notice that you have the problem. So when you start getting into the realms of serious fractions of the full internet routing table, that you'll run into this one. The main symptom is that traffic exiting the network oscillates every minute between two exit points. And the key is every minute. That's the big hint. And this is almost always caused by the BGP next hop being known only by BGP. And that's actually illegal. It's a kind of pick yourself up by, your bootstraps type thing. You can't pick yourself up by picking up your feet because you need somewhere to stand on. So BGP can't use a BGP learn prefix for a next hop. And so you have this race condition, basically, where the BGP BGP router sees that next hop's known by BGP, so decides it's illegal, and then something else takes it away, puts it back in again, and you go round and round the loop as the next hop is removed and replaced and so forth. And it ends up chewing a lot of CPU. If you only have to do this for a few prefixes, it chews 2% of the CPU. If you're trying to do this for the full internet routing table, you've been guaranteed it chews 100% of the CPU. So it's quite easy to troubleshoot with a large number of prefixes there, because it pretty much guarantees your network is not going to work. Okay, so let's look at a picture. We've got router 3 here, and what you see happening is router 3 will oscillate through AS4 or the direct path to get to AS12. And it does this every 60 seconds. The 60 seconds is the hint, because that's how often something called the BGP scanner in iOS runs. It runs every 60 seconds. So every 60 seconds, it spots that it's got an illegal next hop, so it removes that path and installs a valid path to get to a particular destination. And so we end up with this oscillation. So let's look at it to see how it works. So we do a show IP BGP summary. The way you can detect it, the table version number is incrementing quite quickly because the table version will be changed pretty much every time you need to make any change to it. And so if you see this thing going up and you can count the minutes to the time that the BGP session was first started, then you've got a problem. And the number of networks or paths or external, internal routes is changing frequently. That can give you a fairly big hint as well. Troubleshooting it? Well, okay, I've seen this happen an awful lot, so I can recognize it instantly. If you've never seen it before, then, the first time I tried to troubleshoot this, it took me 3 weeks to do it. That was back in about 94 when the routing table was probably 8,000 or 9,000 prefixes, and it was really causing hardship on the routers then because, routers in those days were Motorola's and 8 megabytes of memory and running very, very slowly. So the way to try and tackle this is pick a route from the RIB that is changed within the last minute and then track what it does. So I've picked one here, say 156.1/16, show IP routes, okay, so it's known by BGP, next hop is 1.1.1.1, last heard 53 seconds ago. Lovely. Then we do a show IP BGP for the same prefix, known by BGP, heard from these two neighbors, so through AS4, origin AS12, heard directly from AS12 through 142.108.10.2, but that's inaccessible. That means the next hop is inaccessible from router 3. What does that mean? Well, we have no idea how to get to that next hop. Okay? So this is why this is the best path. That's the best path because it's really the only one available. That's fine. BGP scanner runs. It validates all reachability to all the next hops. So 156.100, now it can use 142.108.10.2 as the next hop because, that's known in the BGP table. Okay, we show IP BG 156.100, so 142.108.10.2, that's been learned, because that prefix has been learned, we now know how to get to it, so that's all fine. We go around again. Let's have a look at the next hop. Well, 142.108.10.2 is known by BGP. That should be the alarm bell. If your next hop is known by BGP, then you have the problem. We do a show IP BGP on this particular next hop, and we see that it's actually a BGP entry /16 heard from these particular neighbors. The issue is that the BGP next hop is known by BGP, an illegal recursive route lookup. Okay, basically BGP is depending on itself. So the scanner will notice this and says, ooh, we can't have this, and it will remove that one from the RIB, and it will put the other path into the RIB. And so if you actually debug the BGP events and the BGP updates and IP routing and so forth, you can see this kind of track going on through the routers. So you scan the routing tables, we have a look at what 142.108 is. It's known by BGP, so we can't have that as a valid next hop. So we reinstall it, but with the next hop going to 1.1.1.1, which is fine. So that's all okay. And then we delete reaching 156.100 via 142.108.10.2 and replace it by going to 1.1.1. Okay, so that tidies up that particular bit. The next hop is now valid. Scanner will detect this, and it says, oh, well, we've got a valid next hop now. So we put it back, we reinstall the other path, because the best path is the other path, because it's closer. So we scan the routing tables, 152.108.16 revised. We delete this path because, the better path is via this one. Add this one in, put 156.1/16 back through the 142.108.10.2 external path. And then that's all done. 1 minute later, the scanner runs, and we repeat this particular slide. Okay? It says, whoops, we can't do this. Next hop known by BGP. And we go to there, and we go back to there, and we go to there, and we go back to there. And every single minute, the router does this. And it goes round and round. Now, if you're doing this for 2 or 3 prefix, you don't notice this. I've seen ISPs have been run like this for years, and they've never noticed. And I've only seen it because I've logged into, the routers to help with some other problem. And I said, well, hang about, your next hop's only known by BGP. Haven't you got this looping thing? No, we haven't really noticed. But high CPU? No, we haven't really noticed. The CPU has been running maybe 10 or 15% on the route processor. It hasn't been enough to bother them. And traffic oscillating out through the edge of the network, the customers haven't complained because, hey, the internet's always very slow or whatever. And life has been good. And it's actually really surprising. And of course, maybe they've suddenly started to multi-home more seriously, or they take a bigger level of the table, and suddenly the CPU shoots up to 100%, and they can't handle things, and they drop peerings and all the rest, and then it's, help, help, we've got big problems. Anyway, so the oscillation is pretty much this. R3 will prefer the routes directly from AS12, like nearest next hop. But when the scanner spots that this is an illegal next hop here, it will install this path as the best path, learns 142.108 as by BGP, then it becomes a valid route, puts the next hop back in, so we end up going back this way, and we just end up bouncing back and forth between those two. Okay, so that's just the whole description here. It's pretty important to make sure that the BGP next hops are known by IGP. I think I've said that one already, didn't I? A few minutes ago. Well, probably about an hour ago. It's really important. You'll end up with this pretty serious oscillation. When I demonstrated this at the workshop I did in Sri Lanka for the South Asia Network Operators Group a few weeks ago. I mean, people didn't believe that it was actually possible to do it. And yeah, well, you can just set it up like this, and hey, look what's happening. We just did the traces through the network, and one minute went this way, then 1 minute it went that way, and it just bounced back and forth. Because basically they didn't have the next hop being announced properly through the network. It was known by BGP and not by the OSPF that we're using. The next hop is also an IBGP. Ensure the IBGP distance is longer than the IGP one, and that can catch some people out. It's really important to make any BGP distance longer than the IGP distance. Or even easier, just don't carry the external next hops within the network. So iOS has the next hop self concept. That's really a much better thing to do. So you've got this set up properly. We're using next hop self, and then you get the true best path this way, and obviously you'll get back up going around that way, and you have no more oscillation at all. The key to this is high CPU utilization, especially if you've got a large number of prefixes. If your BGP process is basically chewing up everything, all resource that your router has, that'll be the tip. Find a prefix that changes every minute and work on that particular prefix. If you've got all 210,000, don't try and troubleshoot on those. It's really far too hard. What about a BGP routing loop? Well, the first thing really is to check for IGP routing loops to the BGP next hops. That's quite important also. BGP loops are normally caused by not following to physical topology in the route reflectors. Most people I know will design route reflectors properly. ISP point-of-presence design is you've got maybe 2 core routers and the rest of the distribution or aggregation roundabout. Generally aggregation in the POP and 2 core routers. Your 2 core routers are the route reflectors. The rest of the routers are the clients. But then some people like designing route reflectors so they've got 2 sitting in 1 city that serves the whole of their entire nationwide backbone. And then don't understand why things break when they've got backbone link failures and so forth. Or the one case I mentioned before, where one route reflector was in 1 city and the other one is another city. Can't imagine why they thought that would ever work. But that's apparently what quite a few have done, and they end up with serious looping issues and just black holes within the network. I don't talk about confederations here or troubleshooting confederations because I've no real experience with troubleshooting any confederation issues because I've never really used them in real life. But multipath BGP used within confederations can end up with some really wacky routing loop problems as well. And of course, lack of full iBGP mesh. If you miss out some routers when you're deploying your iBGP mesh, then you can end up with loops as well. Troubleshooting those is really a case of having a look on each router, picking one prefix and figuring out, looking both at the BGP table and looking at the routing table. They are different tables. Have a look in both of them and compare what they're about. Also check the route to the next hop. That's actually a really, really important one. People often forget about that. How do you get to the next hop? Is it known by BGP? Well, then you've got a problem. Known by IGP, that's fine. Can you actually reach it? Is the IGP telling the truth or not? Some convergence problems. Ooh, my network is converging far too slowly, or BGP is converging far too slowly, or BGP takes half an hour to bring up BGP sessions. Something like this. I mean, this is a pretty old example now. Route reflector with 250 route reflector clients. That's not really a silly configuration. There are quite a few lying around like this. You've got 100,000 prefixes, and you find that BGP will never, ever converge. Why not? Well, if we look at the BGP summary, well, we've got a load of neighbors here, but you see this kind of thing here. You see large numbers of output queue. You probably see input queues, table versions maybe at 0, all the table versions, different numbers, up-down numbers all over the place. Some closing, connects, closing, actives, prefix receive 0, prefix receive big numbers. Generally a shambles like that. What's going on here? Well, you can look at the log messages and you see all these notifications being sent, hold timers expired and so forth. Hold timer expired is actually a very big clue as to what's going on. Hold time expired means you're not getting the keeper lives, so you've run out of the 3 keeper lives before we try and shut down the BGP session. And this has been running for ages, and it's not converging, nothing's happening. What's broken? Or what's actually gone wrong? Well, we're either missing hellos or our peers are not sending them. Now, we could blame our peers, or we can try and look more closer to home. We'll have a look at the interface. What's happening on the interface? Well, here's one example, show interface, gigabit Ethernet. Should be big enough, 1,000 megabits per second. Should easily be able to handle 250 neighbors. Input queue 75, we see 72,000 drops. 72,000 drops since the router started 10 minutes ago. That's a pretty serious amount of drops, especially for an interface this big. Okay, we see that number of drops. It's pretty guaranteed that you're going to have problems with your peers. Well, think about it. You've got 250 peers. And I said the input queue 75. That means there's 75 spots in the input queue. If 250 people are trying to sit down on 75 chairs, well, some people are going to be disappointed. 175 are going to be disappointed. And you repeat this 3 times, certainly in the BGP case, 3 times 175 not get more missing hellos. There's a fair chance that at least 30% of those are going to miss out. So you're going to have, what, 75 possibly missing out on this? Okay, so it's fairly likely that you're going to miss hellos and lose peers because the number of input spots and input queue is not sufficient. And the simple fix is just to make the whole queue big enough. I don't know why the whole queue is still 75. I tend to just ramp it up to something more usable these days. Well, 1,000 is generally what I've put things up, 2,000 in the example here. At least sufficient so that all your BGP neighbors can talk to you all at once. So if you've got 100 BGP neighbors on your router, you've got problems maintaining the BGP session, well, just push the input queue on the interface, that particular interface, up a bit. And that will take care of the problem. It just goes away as quickly as that. And then we just reset BGP. We've made the input queue 2,000. We see no drops, and the BGP is nice and stable. It's quite a simple fix to what can be a very, very frustrating problem for certainly a growing network. What about this one? BGP takes 25 minutes to converge. Well, yeah, you can get a faster processor and throw that at it. Ask your vendor about it and say, yeah, you need a faster processor. Well, not necessarily. Have a look at your configuration first. Tune and optimize the configuration before you just throw hardware at the problem. 25 minutes is a long time. This is just as in the previous example. It's the same sort of case. What's TCP doing? Okay, we've got loads and loads of packets. Look at the number of data packets. We've sent 1.5 million data packets. Sending how many bytes? 818 megabytes. That's a large number. And the key is, or the solution, sorry, the hint is here. Show IP BGP neighbor. The maximum data segment size is 536 bytes. Okay, there's no path MTU discovery running on here. So BGP will just use a standard MTU size. So the MSS is 536 bytes. Oh, so well, MTU is 576. So the MSS is 536. Well, it's fine. It's big enough, but If you had path MTU discovery, certainly if you're using Ethernet, or even if you're using something like optical interface, you could have an MTU of 1,500 bytes or 4,400 bytes. You get a lot more BGP update information into those bigger frames. Right? So 1.6 million packets is high. MSS is very small. So let's enable path MTU discovery. Path MTU discovery basically means that when you bring up a BGP session with your neighbor, or they bring one up with you, the router will figure out the biggest MTU it can use on the bilateral link. And if it's Ethernet, well, 1,500 byte. 1,500 is almost 3 times the size of 536, so you get 3 times the amount of data sent for the same number of packets exchanged. Now that's a good thing. So we reset or restart BGP. MSS is now 1460, which is good. And you'll find that the BGP will come up much faster. In fact, in this case that I tried out, TCP sends 1 million fewer packets. So still the same volume of data being sent, but a large number data packets less. So it's only 600,000 data packets rather than 1.6 million. So you find that BGP will probably come up in about 10 minutes in this example. Oh, well, this I said 15 minutes, okay? It's going to be much, much faster. So it's just a general hint. I just switch it on again as part of standard policy in all the routers. Enable path MTU discovery. Again, I'm not quite sure why it wasn't there from the start, but it catches out a lot of people who aren't aware of it or who don't look at some of the recommended template configurations. And I think, again, there's just the standard router configuration template that Project Kumri mentions, enabling path MTU discovery. So a summary of here, what I've covered for the last hour or so. Use ACLs when enabling debug commands. So basically, don't just switch on any of the debugging commands. Now, if you look in the manuals, it says only use debug commands under direction of technical assistance, whatever. Which is, it's a pretty guaranteed way of encouraging engineers to just switch them on and go and play and see what happens. Which is fine on a quiet corner of your network with only a few prefixes. But if it's on your core router carrying 210,000 prefixes and you do a debug IP BGP, it can end up being very, very frightening, especially if you're logged into the console of the router rather than just by a secure shell session. Make sure that BGP logging is switched on, because that will tell you a lot of information. Make sure that deterministic MED is part of your default template. That's a pretty good idea, just to ensure consistent path selection. If the entire table is having a problem, pick one prefix. Don't try and sort of hammer through all of them to figure out what's going on. Okay, now moving on to the wider field. Internet reachability problems. So we've pretty much figured out all the troubleshooting we can do in the local network. How do we handle troubleshooting when we're connecting to our neighbors or upstreams, peers, and so forth? So in the next 30 or so slides, I've tried to document some of the common things I've come across. I mean, there are no fixed recipes for trying to solve any of these problems. They're just general good hints that I've documented as I've tried to help people solve some of their issues. The first one is BGP attribute confusion. I've seen people who've worked in this for years still mix up what some of the BGP attributes are used for and what they can actually do. If you want to control traffic coming into your network, send MEDs and send AS-path prepends on your outbound announcements. Okay, that's what you do. It's the only thing that you can do, because those are the only attributes you can manipulate. Hopefully the AS-path limit attribute will come into being real soon, and then there'll be another one that you can usefully play to help with controlling inbound traffic into your network. To control traffic out of your network, you have got local preference. You attach local preference to inbound announcements. Remember, inbound, routing flow information runs in the opposite direction of traffic. So inbound routing announcements, manipulate those, it will impact how your outbound traffic flow works. Troubleshooting multi-homing and transit is often hampered because people forget all this stuff. And again, you can see it most of all as people are learning. You probably see it with your customers as they learn to try and do multi-homing for the first time, and they're trying to do load balancing, and they end up, it's like trying to learn to juggle. You don't learn to juggle by picking up 6 balls and having a go all at once at a time. You're going to drop them all. You get one, you learn to juggle it without looking at, trying to follow it around where it goes. And then you add a second one and a third one until you get proficient. And people just seem to have that wrong approach with multi-homing as well. It's like, oh, well, how many balls can I get? Well, the more must be better. So let's throw them all in the air and we'll see what happens and hopefully something works. And one of the things that suffers in all of this is people forget that local preferences for engineering traffic out of your network, and AS-path prepend and MEDs are used for engineering traffic into your network. What else? Each vendor has tweaked the path selection process because, well, each vendor knows best. And those of you who are sitting in multi-vendor environments, well, you probably know this even harder because, well, vendor A has got a completely different idea from vendor B. And, well, okay, the fundamentals of the RFC are there, but you've got a little knob here and a little tweak there that if they're not the same, you can end up with traffic doing weird stuff running around inside your network. So know what it is for your router equipment because it saves a lot of time trying to troubleshoot. And if you're going to go into a multi-vendor environment, then make sure you try and at least keep them roughly the same. Best policy is probably to use the supplied knobs to ensure consistency. So maybe a knob to disable something on one and enable something on somebody else. MED confusion. Yes, this has been a sort of long running pain for many, many years. I mean, we had MED confusion in 1994 and 1995, and we still have it today. Default MED on iOS is 0. It always has been 0. The RFC never said anything about sending MED on an eBGP session. It just made it an optional attribute. So if you didn't send it, well, what was your neighbor meant to think? Okay, if you got a prefix without an MED set, what would they do? RFC doesn't say. And computers can't handle don't know. Computers can handle zeros and ones, and there's no sort of 0 and 1 representation for don't know. So, well, each implementer of BGP had to come up with something. So Cisco said 0. Other people said, 2 to the power 32 minus 1. Other people said 2 to the power 32 minus 2. So when you've got different implementations having different ideas of defaults, then you can end up with really weird stuff. If you send a prefix with no MED on one path to your upstream and prefix with MED 20 to the same upstream on another path, and well, their default MED is 2 to the 32 minus whatever, what doesn't matter, then they're going to think that the best path into your network is the MED 21, not the one where you didn't send any MED at all. So there have been lots of demonstrations about problems caused by this, traffic just going round in circles and so forth. The current practice these days seems to be, rather than using MEDs where there's a potential of confusion, is people just to use communities. Different ISPs will implement communities to do their load balancing, and you use that instead. So that's certainly one workaround. What else? Setting community in a route map does just that. Communities disappeared is a frequent question. Well, how does a community disappear? Well, because I've done set community here. Well, set community on a BGP announcement will actually override any communities that it already had. If you want to add your community to the existing ones, you need to use this additive keyword within the configuration. Okay, so that's a frequent problem. I tend to like using the internet format for community, so AS number : something, rather than the 32-bit IETF format. I'm not very good at handling, well, numbers between 1 and 4 billion. Computers can do that. They don't care. But a human-readable representation is much nicer in the AS number : something for the communities. And I guess that's the same motivation that the 32-bit AS number folks have for using the number dot something, even though it makes it a bit more interesting when you're trying to do regular expression matching and so forth to handle those. But as I say, the router representation does not matter. It doesn't care. It's a 32-bit integer. But human readable, that's a different issue. Okay, so the AS : blah is a lot more intuitive and recognizable. Second community confusion issue. Cisco iOS never sends community by default. Some implementations send it for iBGP. Some send it for everything. So if you're sitting with multiple implementations, be aware what each one does. If they're different, then you can end up with problems. Never assume that your neighboring AS will honor your no export. And I've seen this quite a bit in Australia. Oh yeah, I'm going to send blah, blah to whatever, no export to my upstream. And of course, upstream doesn't support any communities whatsoever, so the prefix leaks out into the internet. It's actually one of the excuses I've heard for all the deaggregation that's going on in the internet. Oh yeah, it's just people not supporting no export. Well, I've actually seen too many configurations to know that this is not the case. But there are cases where people have sent no export to their upstream or to the peer, and it hasn't been honored. So if you're going to do that, ask them first. And if they say no, then you've got to figure something else out. Oh yes, AS path prepending, one of my favorite hobby horses. 20 prepends will not lessen the priority of your path any more than 10 prepends. But some people seem to think if I do 20 prepends, it's going to make it a lot less important. Well, if it's 20 prepends and local pref 500, it's going to beat anything that's local pref, well, 0 or whatever. Okay, so, but some people seem to believe that prepending will really override. If I do a massive prepend on a /24, then, well, that means my /19 that is the supernet of this is going to work. No, because /24 is more specific. Really, but doesn't prepend beat this? I've had these conversations. I only had that conversation 2 weeks ago. The internet actually, on average, is only about 5 ASs deep. I mean, if you look at the CIDR report or the routing report that I send around, that's what you see. Average AS path, 3.6. From my view in Japan, if you look at the European internet from Japan, it's about 4.4. That's the depth of the internet. It's not that deep. Longest AS path that I see without AS path prepends is only about, what was I forgotten? It's about 15 or 14 or 15. That's the longest one I've seen. Sequential ASs that are all different. I mean, you can look at the prepended ones. There's some guy at the moment doing a 20 times prepend. I had no idea why, because he's only announcing a /24. And that's all there is. There's no covering aggregate or anything. So maybe it's just for fun. Some ISPs actually use this thing, max AS limit. What this does, it will drop prefixes with AS paths longer than 15 ASNs. Okay, so if prefix comes in and the AS path is 30 long, boom, it'll be ignored. Okay, some people put this in. Was it a couple of years ago there was an issue where somebody discovered that there was an overflow bug in one implementation where if you sent an AS path that was more than 255 ASs long, you could crash the router. And well, so ISPs since then have been protecting their eBGP peerings by putting something like this in. Probably not quite as aggressive as 15, probably about 30 or something like that, but some ISPs are actually doing this now. Private ASs should not ever appear on the internet. But you know, they appear from time to time. You look at my routing report, they're there. People like announcing them. There's a remove private AS command. I know Juniper has an equivalent thing as well to strip out private ASs. Just put it in your BGP template. The Project Gumri one has it. It's in the BGP template there, so put it in your one. But sometimes the private AS, I mean, this private AS removal command doesn't remove every single instance. If there's a public AS number behind the private AS, then the private AS won't be stripped out because it's a configuration error. But some people don't understand this. It's not a bug, it's a configuration error somewhere else that needs to be fixed. Okay, so I'm just going to look at a generic sort of troubleshooting case, and I'll just wander through this in the next few slides to show how you might try and tackle it. And the symptom is this. AS1 is announcing 192.168.1/24 to AS2, but AS3 cannot see the network. So AS2 should be providing transit to AS1 to reach AS3. Okay, so you've got the situation. How do you go about troubleshooting this? Well, here come my checklists. Make lists. Try and do the checklist. Start at the beginning and work through it. Don't automatically blame your neighbor for the problem. So AS1 is announcing the prefix, but does AS2 see it? Well, here we're actually checking the eBGP filters on router 1 and router 2. Router 1 was an AS1, router 2 was an AS2. Check the filters. Can R2 actually see it? Don't send an email to your neighbor demanding access to their router. Get them to actually check that they can see the prefix. Get them to send you BGP output. And if it's there, then, well, you can look further afield. Does AS2 see it over the entire network? Okay, check that they've actually got the iBGP working properly. Check that they've actually got next hop reachability. Because even the prefix can be seen. If the next hop is not valid, they're not going to send it to their neighboring ASs. Okay, so check that the iBGP is working. properly. So it could be lack of full mesh, incorrectly configured route reflectors, anything like that. Does AS2 send it to AS3? Well, in this case, we're checking the eBGP configuration in router 2. There might be a configuration error with the AS path filters or the prefix lists or communities such that only local prefixes get out. And that can happen quite often. Somebody may have forgotten that they're providing transit to AS1. And go, oops, I didn't update the filter. Or it could have been a typo or anything. Does AS3 see all of AS2's originated prefixes? Well, I mean, they may not see your prefix, but maybe they'll see all the prefixes coming from AS2 instead. Well, if they do, then suspect inbound filters on AS3. Does AS3 actually know it's going to hear anything from AS1? This is a classic filtering problem. Whether it's a case of, somebody hasn't updated the internet routing registry or whatever, this is generally the case of what's wrong. There's a filter lurking around that somebody has forgotten to update. Now, notice in all of this, you can't just send an email from your network to some remote AS saying, why can't I get to your network? Something's broken. They're going to say, who are you? Okay? You need to work the relationships all the way through. So you need to talk to your upstream ISP. He's got the relationship. So AS2 will have the relationship with AS3 in this example. Okay, you can't just bypass your upstream and talk to their upstream or their peer, because they're basically going to ignore you. So work the relationships through the system. Okay. Right, what about this second example? Symptom here is AS1 announces, 203.51.206/24 to its upstreams, but AS3 cannot see the network. Now notice here the upstreams are the internet. So AS3 is the other side of, wherever, it could be the other side of the world, other side of the network somewhere, and you have the wonderful internet sitting in between. Well, you can't work the relationship thing here. Okay, you can't talk to your upstream who'll talk to their upstream, their peer, their customer, their customer, their customer, all the way through the network. The message will get a bit garbled and a bit lost by the time it works its way through. So you need to try and do something else. Well, again, you work your checklist. AS1 announces, do the upstream see it? Check your filters, check the upstream's filters. You need to have a nice relationship with your upstream to actually get access to it. If you don't get on well with your upstream, you probably should change them, because you need them. You'll need their help in times of trouble. And this is certainly something that some parts of the Asian internet don't get, and that is you have to have a good relationship with your upstream. And it's like, they always keep asking me, why? Surely it's just I want to take the cheapest service. Well, and if you take the cheapest service, then you might not get the relationship that you want. What happens if there's a denial of service attack, or BGP configuration problems, or reachability problems, and you need your upstream to help? And if they treat you as, a cheap customer because, you're paying them $5 a month for internet access, they're going to give you $5 a month worth of attention, which is probably just delete or something. So it's more than just a financial relationship. But anyway, it's still hard work trying to explain that. So you need to have the good relationship with the upstreams to try and work through this, because without it, it won't go anywhere. The second thing is the prefix visible anywhere on the internet? And this does not involve sending a random email to, random mailing lists saying, hey, can you see this prefix? And don't send an email to the NANOG list saying, hey guys, can you see my prefix? And it's like, yes, there will be helpful people on the mailing list who can check. But there's so many tools out there on the internet that will let you do this job for you. Looking glasses. There are hundreds of looking glasses all over the world. I mean, it's not just a sort of few looking glasses in North America, none anywhere else. There are looking glasses everywhere. And since the first few appeared, the software has just been distributed everywhere. Pretty much, not every ISP, but most ISPs have got a looking glass of some description. Okay. Go to traceroute.org for the V4 looking glasses. The V6 looking glass site has all disappeared, which is a big shame. You can get some of them there in bgp4.as. Get some of the V6 looking glasses sitting under there, but the traceroute6.org website has vanished, which was a bit of a pity. Some ISPs, especially those with... Yeah, tell us what you... Microphone doesn't work, so I'll repeat the question because the microphone's not working. Okay, so the comment really is that traceroute.org now has both the v4 and the v6 because there weren't many requests for a separate v6 one. Yeah. Okay. Thank you. So some ISPs as well, especially those with large and diverse networks, they'll have their own internal looking glasses to aid internal troubleshooting. Those can be pretty useful as well. I mean, I've looked at a few of those just to get ideas of different views within the network. And, well, I've just put in one example. I mean, I've no real reason to pick the RIPE NCC looking glass, but I find the risk pretty interesting for other reasons as well. So I put it up here. It's just a nice, easy, accessible one. And so the example I worked through, well, I've picked the route collector sitting at the links in London, and so just from the nice menu, and I've got this thing, and I want to do a show IP BGP. It's probably not visible on the screen, but if you're following along the slides, you can see it. Show IP BGP, and I've put in the prefix that I want to do a show IP BGP on, 202.173.147.0, and so I've got, actually that's not the prefix I used in the example, but anyway. 202.173.147.0, so it's given me a BGP table for that particular prefix. And, well, there it is. So I see different paths, and that all looks fine. Okay, so the looking glass can see 202.173.144.0/21, so that's okay. And that, of course, includes the /24 I was trying to troubleshoot. So in this particular one, looking glass can see it. So you'd obviously go and check a few others just to try and narrow things down. So where would the problem be? Well, the problem must be closer to the destination that you're trying to reach, because if looking glasses can see your prefix, yet you can't access the site, or the remote network claims they can't see your prefix, then the problem must be closer to home. So maybe you do a trace route, and you can do a trace route from the looking glass as well. You can trace from your network all the way back. So I've traced from, well, the looking glass at links in London all the way back to my home DSL link in Brisbane in Australia. Okay, so it's wandered all the way across the internet back there. So the trace works fine, so that looks good. You can also use route views. I find route views pretty useful as well. The main route views router, I think there's several routers actually in the service, but the main router's got BGP feeds from around 60 peers. You can go and have a look at that. There's a whole lot more information there as well on the website. But it's actually pretty useful just to check BGP tables. Only you'll see 60 paths to each destination. And that's generally, it's a nice simple thing. I just telnet into it and do a show IP BGP on the prefix I'm looking for. And if it doesn't show up, then, well, if route views doesn't see it, then pretty much it's not anywhere. Because route views has BGP views of several ISP networks from all across the world. Anyway, getting back to the problem. So we reckon it's somewhere in AS3. So does AS3's upstream send it to send the prefix to AS3? So if AS3's upstream has got maybe a looking glass or something, you can go and look at their looking glass and see if they see the prefix. And so that's where you're sort of narrowing down where the problem might actually be. Okay? So it could be a configuration what AS3's upstream is sending to AS3, or maybe AS3's actually actual inbound filters. Maybe they've got a policy, we don't want to hear /24s. Or maybe they've got a policy, we don't want to hear prefixes smaller than minimum allocation from registries. Or maybe they've just got prefix filters that were installed in 1999 and haven't been touched since. If you think that I'm joking, I am not. I have seen more than enough of those lying around the world. I won't tell you about my Mongolia story because I've told it the last NANOG. But that was one classic example that internet disappeared and caused by these filters. So these can all be issues. Lingering old configuration that people don't remember or don't know about, or they're too afraid to touch, or maybe some BGP consultant came in and said, don't touch that, if you touch it, you'll break the internet type thing, which I hear a lot of. Troubleshooting across the internet is harder, but I mean, actually the looking glasses are pretty useful in helping there. They can do trace routes from them. You can use ping. You can look at the BGP status all across the globe. If you're running a looking glass and it's not on the traceroute.org site, volunteer it because it's a helpful tool for assisting with a lot of troubleshooting. If customers complain that they can't reach such and such a website, don't just say things like, oh, well, it's probably down. Point them to a looking glass. You won't hear from them for days because they'll go exploring all sorts of other things. And it's quite interesting. I send ISPs off who've never ever heard of the traceroute.org website. Hey, go and have a look at this. And they're amazed because they go, oh, there's such and such in this country, and they go looking around and so forth. Once people discover how to do some of these things and what to go and look for, they'll go away, and there's a lot of self-help, a lot of people actually willing to help themselves. And they get more put off by the go away, you don't understand, or go away, the internet is just not reliable type answers. Give them some access, give them some ideas of things that they can use to help themselves. Anyway, let's get back to this. Oh yeah, troubleshooting multi-homing or load sharing problems. Okay, we can do all the multi-homing tutorials and explain people how to do stuff, and then I've set it all up for them, and then we get things like this. Oh, I'm trying to load share, but traffic doesn't go through one particular AS, and I've done everything you said, so there must be something broken. Well, yes, there's something broken. You need to go and troubleshoot it. Go and look at all the looking glasses. Well, yes, but they don't help. Well, here are some more troubleshooting tips that you can use. Again, build another list. You need to get the complainant to define what trouble actually means. I'm having trouble load balancing. Well, yeah. It's a bit like getting emails saying, such and such doesn't work. Well, what doesn't work? Can you explain what the symptoms are? I mean, what do you see? What do you not see? What were you hoping to see? Things not working emails are not really too useful. Is outbound traffic load sharing okay? You can usually fix this by selectively rejecting prefixes and using local pref. Okay, that's just standard multi-homing stuff. So if you can send traffic out all right, then you're fine. So that's a local problem. Outbound load balancing is easy because that simply depends on the prefixes you send in, you accept in. What about inbound traffic load sharing? That's always a problematic one. You need to do some troubleshooting on this if you're having problems here. Communities you can use ASPath prepends, MEDs, and all the selective leaking stuff. If none of that works, then you need to do something else. So what do you do? Well, AS1 announces a prefix. Does AS2 see it? We check the filters. Oh yeah, remember we've done all this this checklist already. Okay, do the checklist just in case. You never know. There could be a misconfiguration somewhere. Okay, do all the usual thing, checklist, does it all working? So if all this works for all the different ASs, and everything seems to be fine, but you still can't figure out what's wrong, don't resort to the common solution of, oh well, I'll just do a massive big prepend and then it'll fix it. ASPath prepends towards the AS where all the traffic is appearing from will not solve the problem. Okay, here's some things you can do. If there's no inbound traffic from one peer, and yet you're sending prefixes, well, try and work out what's wrong. If there's no inbound traffic at all, then maybe AS2 is not seeing the prefix. They could have just blocked it with filters. If there's a trickle of inbound traffic, switch on NetFlow. But NetFlow I thought was meant to be a sort of security tool. Well, NetFlow can be used for loads of other things as well. NetFlow tells you where traffic came from, where it is going to, source address, destination address. Source address is a massive big hint for inbound traffic, because if the source address range for NetFlow is only from your neighboring ISP's address block and from nowhere else, you found your problem. It's because your neighboring ISP is not announcing a prefix anywhere, or somehow traffic is not coming from their peers or their upstreams through the network. Okay? Yeah, you can do that with NetFlow. And that helps troubleshoot what the problem is. I mean, if you can then approach them with this problem, and if they claim, well, but we're announcing it, well, send them the show IP BGP output, go to Looking Glass and say, well, look, I don't see your AS in the path. Here, look, this is what NetFlow shows me. There's nothing coming from anywhere apart from just your AS. What's going on? Who's doing the filtering? Okay, you need the evidence to show to others. If it's a light flow of traffic, but it's less than 50% from AS3, and you've tried all the load balancing tricks you know of, well, have a look at the Looking Glass. That's where you really need to go there. I mean, AS1 may choose primary path going to AS2, but AS2 and their upstream may have decided this is the backup path. So AS2 might have said, oh, well, this customer, oh, I'm going to help with my load balancing. So this customer, I'm just going to do a 10 times prepend, and all the traffic to my customer will actually go around some other way. Well, but if you've decided that AS2 is going to be a primary path, this is really going to mess you. So you need to have a conversation with the upstream and saying, I'm trying to load balance between you and somebody else, and can you sort of do the proper preference so it doesn't mess me up? Again, NetFlow can come to the rescue here. You can see where the problem sources are and try and figure out the relationship of those sources to your upstream. Okay, the load sharing between the upstreams is swinging randomly between AS2 and AS3. Yes, that can be a very confusing one to try and fix. Well, we do all the checklists that I mentioned before, check the filters, blah, 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 and so on. Okay, configurations look fine, looking glass looks fine, life is wonderful, apart from these annoying traffic swings, which probably happen every hour or so. So what's the problem? Is it layer 2 problem, upstream ISP problem, route flap damping? Well, these all can actually interfere with it. If BGP is configured properly, then, and the network's been stable for a long time, then it only really can be layer 2, or flap damping is somehow causing some side effects. So layer 2, upstream somewhere is poor connectivity between themselves and the rest of the internet. Well, all you've got to do, you can go and whinge at your upstream. It's probably less so of an issue in North America, but it's more so of an issue in other parts of the world, where the upstreams tend to be reachable through satellite links or unreliable undersea links, especially through earthquake zones and so forth. And similar situations like that. If the upstream is very cavalier with how they deal with their customers, then you need to go and tell them, look, this isn't good enough. I need a reliable connection. Fix it or I move. Some places they can't do this. Some places you simply can't take your upstream. You've got to take what's presented to you. What about flap damping? Well, many ISPs still, for some reason, implement route flap damping. Many ISPs still read vendor documentation which says, this is the greatest thing ever invented. Actually, the vendor defaults, I mean, all the vendors I know of, are far too severe. Because, well, when flap damping was first coded, nobody really knew what the defaults needed to be. So it's a case of pick a number and stick with it. And as you know, trying to change any default is, well, pretty much impossible. Well, you know, then the internet community in Europe came up with various RIPE documents that had more lenient values. Well, the more lenient values are actually far too severe as well. And actually, I should have updated this, but RIPE 378 came out last year, which basically said flap damping is really, really bad thing because it actually makes things a lot worse than they could be. So that's just one example here. My apologies, I should have updated this slide for this tutorial. But you can find out the impact of flap damping from looking at the different looking glasses. Some looking glasses where you can show the BGP table will actually show you the flap status and the damping status of different prefixes. So I've got one example here. This is Sprint Links 1. Again, I didn't check if this still works, but it worked a couple of years back. But it's probably too small to see. But this column here, you can see the prefixes that have history attached to them. In other words, they used to appear in the BGP table, but they have since vanished. So you can find out flap damping status. So if your prefix appears as being damped or it's got history and so forth, then you know that you've got some problem somewhere in the network between you and the other end. Okay, so many oscillating connectivity issues caused by layer 2 problems. The thing is, if one ISP in the path has a problem, maybe they've done some maintenance on the network, they've rebooted the router, you see the impact of this reboot ripple through the network, and you have this thing called flap amplification happening. So even if there's only been one reboot, so one instance of something happening, you could see maybe 5 or 10 withdrawal messages by the time it's got anywhere else within the network. And those large number of messages could be sufficient to make you disappear from the network. And so the oscillation you see between your upstreams can be purely down to that, as BGP does the path hunting, as the timeout from the flap damping timers expire and the paths become valid again. And it's quite amazing. It's like you're hitting a gong, and the gong will resonate for a long time on. It's not just a case of hitting something like a concrete wall. Concrete walls don't resonate. It's just clunk, and that's it. Whereas if you hit a gong or anything like that, it will ring on and on and on for quite a long time. And that's the impact that flap damping has. So it can have a serious impact. And having worked with many ISPs in this particular area trying to sort these sorts of problems, it's pretty much always been down to flat damping married with an unstable upstream ISP or a cavalier upstream ISP or upstream ISP just not being careful with how they handle their BGP on their routers. Okay, summary of this. Most troubleshooting is actually, well, it's about experience. When I was first started doing all these, I was asked, well, can you do a BGP troubleshooting tutorial as well? And I was like, well, yeah, but I mean, troubleshooting is very, very specific to a network. I mean, the troubleshooting I did at UUNet in Europe, I couldn't really talk about that here because the situations and circumstances are different from what anybody else would cover. If you have had a well-run network and has never really had problems, you've never really had to do troubleshooting. Whereas if you have a lot of infrastructure issues and a lot of relationship issues with other ISPs, then you've probably had more troubleshooting to do. So it's really down to experience and gaining experience trying to figure out what's going on. So what I've tried to do here is give you some of the common problems. And if you can recognize some of these common problems in the network as they happen, and if I've saved you maybe a week of banging your head against a wall, then that's great, because that's probably all I can really achieve. I mean, as I said at the start, if you've got some pet solutions to particular situations or problems that you've solved, then by all means come and present them here, because it would be a valuable addition to some of the basic things that I've actually covered. Third point here, well, second troubleshooting point here is don't panic. Those of you who are Hitchhiker's Guide to the Galaxy fans will know that. It says don't panic. It's important not to panic. Really, really important not to panic. The good troubleshooters are the ones who just sit down and methodically work through the situations. Now, I'm pretty lucky I don't panic about too many things that are happening, but that's kind of got me a reputation of being a good troubleshooter, which is a pity in a way, because then people say, oh, I've got this problem, can you please help fix it? And I really don't have much bandwidth to try and help with all these sorts of things. Stick to a logical approach. I know some people are probably more logical than others, but if you stick to a logical approach, check the simple things, the obvious things first before you get more complicated. Okay, it's probably not going to be as basic as is the router switched on, but work out from very, very simple situations like this and then look for the more complicated things. Don't blame others. Have a look around your own network first to make sure the situations or the problems are not there. Then start having the conversation with others. I mean, if the first method of trying to troubleshoot your network is to attack somebody else, they're not going to help you later on when you need their assistance for problems. Troubleshoot the layers in order. So start with layer 1, layer 2, layer 3. Trying to start off at layer 7 and working downwards, it probably wastes an awful lot of time. And you'll need to do layer 8 and layer 9 involvement as well, probably keeping managing directors and CEOs off your back for half the time. Use the tools that are available. So get to know the tools that are available on your router hardware. It pays to actually sit down and figure out some of the debug tools that are available and how to use them. Because if you're in the middle of a crisis and you don't know how to use the tools, you don't want to sit on the phone with a technical assistance engineer trying to figure out how to troubleshoot things. Internet looking glasses are wonderful things. Colleagues and their knowledge are wonderful things as well. People are not going to shout at you because you don't know something. People are generally happy to help. I mean, even the NANOG list, sometimes people are happy to help with things. It's not always just people shouting at each other and lots of off-topic comments and so forth. People are actually willing to help. I'll say public mailing lists where appropriate. Okay, there are lots of public mailing lists to help with different things, the vendor-specific ones, the various NSP ones that Jarrett Mouch has been looking after. Those are all really, really useful for helping with situations like this. Okay, so I've done the most common things. I encourage anybody, if you've got your own pet troubleshooting things, to please stand on this podium at the next NANOG. Well, obviously not here, but in Seattle, at the next NANOG, and cover some of your things, because I'm sure there's a lot more than what I've just presented here. As I say, once you've mastered what I've covered here, you can do more complex stuff, and then you can come and talk about it. I'd love to have your feedback, if there is any feedback. Future improvements, I'd love to know those too. If you're afraid to present on your favorite troubleshooting techniques, well, tell me what they are, and I suppose I'll do it on your behalf. But, it's much better to have other people to be talking heads here. And that's it. Thank you very much for listening.